Good morning again. Good afternoon, Danilo.
Good morning. Ciao, ciao Pete. Hi everybody.
All right. We're back for day 2 of our Generative Edge AI program, which is cool. So Danilo, so I'm Pete Bernard, CEO of the Edge AI Foundation. Danilo, if you want to introduce yourself as our host.
Yes, Pete. Danilo Pau, ST Microelectronics in System Research.
Fantastic. Yes.
Hi everybody.
And you are in Milan, right? Are you in Milan?
Yes, and it's 5 p.m. CT. Yes.
Oh, okay, good. And this is a live stream, so we got a bunch of people tuning in. Feel free to say hello and where you're from in the chat. We always get a good sampling of time zones, and I apologize in advance for folks in Asia where this is way past their bedtime. But the good news is it's streaming on YouTube, Twitch, and LinkedIn, and it's recorded on YouTube. So if you're not catching this live, then maybe you're watching it on YouTube, which is okay too. Nothing wrong with that. We have a really packed day ahead of us. We had, I don't know how many speakers yesterday. I lost track. It was like a dozen speakers, I think. And today we have almost as many. And we're going to be talking about all the latest and greatest in generative edge AI, agentic edge AI, what's happening in the space, and taking questions as we go, which is going to be pretty cool. So this is the 4th installation of this. We started this in spring of 2024. So we do this every 6 months. And every time we do it, there's more talks and more information and more stuff happening, which is good. So Danilo, any words of wisdom before we kick it in?
Thanks, Pete. Well, we have very good sessions today. We will hear from McKinsey with you in a fire chat, and then we will have a couple of sessions with a lot of top speakers. So eager to hear from them.
Awesome. And I see we have folks here from the Netherlands, from India. Hello, Atul. Chris from Atlanta, Georgia. Some Toronto, Canada folks here. France. Awesome. Brendan from Ireland. So, yeah, it's going to be a good crowd. And what else? I think those are all the words of wisdom that we have. If you have not subscribed to our YouTube channel, you should probably do that, and you get notified of all these fun things. We put out a few videos every week. A lot of talks from people from the industry, kind of sharing their wisdom and insights from the Edge AI universe, typically pretty technical talks. And you can go to our website, edgeaifoundation.org, and learn all about what we're doing out there in this space, which has been a lot of fun. So with that, Danilo, should I shift it over to Martin?
Yes, please. Let's
right.
start with your fire chat. Yes.
Sounds good. So I'll bring Martin on, and Danilo, I'm going to give you. You're still there's a little bit of lag still on your stuff, but maybe you can take a look at that. We'll see. It is what it is. It's the internet. Okay, so sounds good. Martin, welcome.
Good morning, good afternoon, depending where you are.
Yes, or good night if you're
in India, yes,
or Japan. I think there's someone from Malaysia on the call, so we'll see if that's. But yeah, great to talk to you again. I know we spoke a couple weeks ago, a week or two ago. I think I was in Korea at the time. Speaking of time zones, was I in Korea? I think so.
Yeah, I think you've been in Korea because it was for me a time not matching to the US time zone.
Yeah, it's always challenging, but now I'm back and I'm over my jet lag, so that's good. But yeah, good to see you. So we're going to talk a little bit about, well, we use the automotive market as kind of a proxy. And what I think was really interesting when we talked was that, and we'll bring up some data, is that you took sort of a voice of the customer perspective on generative Edge AI, generative AI scenarios for automotive. And you said you had sampled around like 25,000 end users. Was that it?
Yeah, we are doing a global consumer survey launching in Europe, US, Japan, China every year. I think it's 20,000 participants. And we ask about everything around mobility. And we have also asked, and I think if we pull up the slide, you can see it, about Gen AI. And 46% of the people we have asked see that as a key megatrend in mobility. And I think this text in small is also important, with the potential to create valuable new use cases and change the mobility sector. So half of the people we have asked, and that was already in 2024, see that there's a extreme potential of Gen AI, similar to circular economics, and even more important than carbon neutral mobility.
Interesting. Yeah, I see that. What is circular economy, by the way? Can you explain what that label means?
Yeah, so it's like really reusing, extending the life of the vehicle, but also mainly reusing the parts of the vehicle and into a second life. Could be, for example, the best example is a battery, which you then use not just in an electric vehicle, but then as a stationary energy storage after that.
Oh,
so
I see. Okay, yeah, right.
Reuse all the parts.
Got it.
After the first life.
So this is about 20,000 end users across many different regions, right? It wasn't just Europe. You had US in there as well.
Yeah, China, Japan, Europe, US.
Wow. So 20,000 is a pretty good survey. So it's interesting. So you positioned a bunch of different things toward them, and so they picked Gen AI as kind of the key thing for creating new use cases, which is interesting. I've never seen that before, but can you give us a little more insight as to what does that mean? Because Gen AI is a term that's interestingly kind of made it into the public sphere. And so people have been using chatbots and things like that. But when they think about it for cars, I'm curious, like what are
we have, as mentioned, I work in the intersection of automotive, AI, and software. And we basically did a small survey. So that's not the consumer survey. This is really, we have asked people in the industry, where do we have at the edge AI? So inference on the car, what does it now change in the vehicle, in mobility? And 50% of the participants said the main use cases in advanced driver assistance systems and autonomous driving, where you can now shift from a rule-based algorithms to like end-to-end models, which include perception, motion planning, and partially also control, and really getting ADAS to a really new customer experience level. Or the second use case, and that is in-cabin safety. 29% mentioned infotainment and comfort features. I think that's most known to all of us, that you can also have voice assistant personalization in cars. But there are also a couple of other use cases, maybe less known, but also very important, especially from the OEM perspective, that you do, for example, network health analysis, intrusion detection, keep the cars safe from intrusion, but also predictive maintenance, detecting the potential errors much earlier, and then saving cost in the aftermarket and on warranty and repairs. So many use cases really changing, not just what is obvious, adding voice control, but really adding something on ADAS, but also safety, security, predictability of errors. Many use cases, which is why everyone in the automotive industry is really excited about that.
Yeah, for sure. And I can see like the top two are kind of more human machine interface type of scenarios, and the stuff below, I think a lot of folks working in Edge AI are familiar with, in terms of anomaly detection and other types of, mechanical health analysis, ambient noise cancellation. I mean, we're seeing that happening now, like with AirPods and hearables, and using audio AI for that. And in fact, we've had some talks on this live stream, previous live streams, talking about kind of motor optimization, I would say, in drones. Like, how do you optimize drones for extended battery life by using Edge AI and TinyML and in those motors? So I can see all the stuff below. This maybe not as visible to the end user, but would be also pretty valuable in terms of getting more out of the equipment in general. So it's good to see that people have that at least top of mind. And then, I think the top stuff, like you said, the voice assistants and the personal recommendations. I mean, that seems pretty straightforward. I think that it'll be interesting to see how those actually get deployed. What's the other inside stuff that you got out of this thing?
Yeah, so if you say deployed, I think the important thing is like end-to-end models for ADAS. They're already in the field. So if you drive a Tesla, I think after version 12, you are using basically end-to-end models. Also, if you look at different OEMs, they have already voice assistants using Gen AI. So a lot of stuff already on the road and not just like future stuff.
Yeah, no, for sure. And every time I'm in San Francisco, I take the Waymos there, so I make sure I get my self-driving car fix. So that's good to know. Good to know there's demand out there, and like you said, there's been some deployments. And I guess what the survey is saying, the guidance should be really around some of these top scenarios and making sure that automotive makers nail those. I guess there's also be a proxy for just in general, customers are starting to get more educated about what generative edge AI or generative AI can do for them in terms of their equipment and experiences. So that's good to know as well. That's cool. What else did you learn from the survey?
I think what we also learned, so we are talking about automotive. There are some similarities, but also some specific things which might be also true for other, let's say, embedded devices, where we are not talking about phones or computers. But what is the main reason to deploy inference on the edge? Why deploy the large language models on the edge and not in the cloud? And I think here, based on the survey, there are four main reasons. The first one is offline availability. Just think about your ADAS system. It still needs to run if there's a loss of connectivity if you go through a tunnel. So this is really, in a lot of these use cases I've mentioned before, you also need to have them while you're not connected to the internet. So that's one of the main reasons to deploy on the edge. There are some use cases like, for example, noise cancellation, or also ADAS systems where you cannot wait to transfer the data to the cloud and wait for the feedback. That's just not safe. Then it's improved data and security and privacy, but that's, let's say, a less important reason, that the data is only processed locally and not uploaded into a cloud. And then also for some use cases, if you would, for example, need to transfer full images, then it's also a matter of decreased networking traffic by running the inference on the cloud.
Yeah. And this kind of maps to the kind of general value prop of edge AI in general. Like we have there's an acronym I use called BLERP, BLERP, bandwidth, latency, economics, reliability, and privacy. And it sounds like this kind of hits all of them. Although in this case, it's kind of stack ranked for, I would say, reliability, offline availability first. So that kind of tracks, which makes sense. So what else do you got on this thing that's helping?
Yeah, maybe I now just had all the good things, but there are also some challenges. And some of them, I would say, specific to vehicles, others less. But same survey where we asked what are the four main challenges, and there are two hardware, two software challenges. I think on the hardware side, it's still SoC resource constraints. I mean, if we are on the edge, we have not unlimited power. It's computational power, but it's also, especially like, where do I store the model? So, and on the execution, the data throughput, the high bandwidth memory are a couple of things which were mentioned a couple of times, that's currently like a constraint, and the constraint in two things. Like the first one is the availability of these high performance chip in automotive grade quality, but then also the costs, because of course, if you're talking about an ADAS system, it should not increase the purchase price of a car significantly. So this is why cost always matters for these kind of end customer vehicles. Second is energy consumption. So especially like for high energy consumptions for SoC during inference. And two other things more like on the software side, the updatability of models is difficult given the large size and the way over-the-air updates are done. And then the last one, it's only 4%, but still want to mention it, that it's still missing good frameworks for the ops part of machine learning and for example, updating the models in an automotive context.
Yeah. No, I could see that. Again, this kind of tracks to a lot of, like you said, general edge AI challenges. And although I would say automakers are notorious for not understanding how to update their software, but I think Tesla and some of the newer folks have figured that out. But yeah, I could see that the main thing, and the good news is, I think from year to year, we've seen a tremendous increase in the kind of ops per watt or performance capabilities of some of the SoCs and platforms, especially with the kind of outboard accelerators that are coming to market being used with CPUs too. So that's a good thing. But this seems to track pretty clearly. I think the last one, software frameworks for deployment, yeah, it kind of just makes it difficult for device builders and solution providers. So especially if you want to move models from one platform to the other, but there are solutions for it. It's just a little bit tricky sometimes. But yeah, this seems to track pretty well.
And sometimes, if there are solutions, it just takes a little bit longer until they end up in the automotive field, given long development timelines. Right. Especially if you're talking about safety critical devices and functions.
Yeah, no, I can imagine like kind of the automotive market's kind of at the bit of the tail end in terms of deployments, because obviously things need to be certified safe and pretty bulletproof as they go out to vehicles. So yeah, that kind of makes sense. I saw in your footnote there 28 gig for a 7 billion parameter model, and that's assuming 4 bytes per parameter. So that's an interesting data point. I had seen data that was more around a gig per billion parameter, but maybe that's with 2 byte. But that's an interesting data point for the audience to think about. Typically, the generative edge AI deployments are somewhat memory bound more than TOPS bound. And so the cost of memory into these edge devices is one of the primary issues right now. So as the models get more efficient and smaller and more quantized, that'll actually bring down the memory costs a little bit. That'll help with kind of 0.1, I think. But yeah, that looks pretty cool.
Maybe I think what we also did, like this was not like in the survey, but based on interviews, how the chips are changing, and we see that for different use cases, CPUs remain important, especially like in the automotive ADAS context, safety critical, being the orchestration layer for the full SoC, managing deterministic workloads. We see that general GPUs are increasingly outpaced by specialized by NPUs, or more specialized for the tasks. NPUs are getting more and more important, especially if we are talking about the ADAS domain. DSPs also lose a little bit the importance going forward.
Yeah, that makes sense. I know that also, like kind of the first gen NPUs, the outboard NPUs tended to be more computer vision oriented, which is a different architecture than kind of transformer-based models, which is generative edge AI or generative AI oriented. So now we're seeing more NPUs coming out that are designed from the ground up to be more of an accelerant for transformer-based models. So there's a world out there of folks that with outboard NPUs. But one thing to keep in mind is that they're now transitioning to be more tuned for generative AI models as opposed to vision AI models. So that's interesting to see that. And I agree. I mean, the general purpose GPU, especially DSP, yeah, valuable for things. But I think for accelerating Gen Edge AI models or Gen AI models, these new NPUs, outboard ones, are kind of where it's at. And then eventually those will migrate into more kind of integrated SoC solutions, right? But that seems to be kind of the hot space. So I think what you're saying is for folks designing these systems, probably the NPU is one of the most critical components to have in there, right?
Yeah, and taking increasingly share of the full SoC, like if you just look at the space.
Makes sense for sure. Good. Well, let's see. I'm seeing if there's any questions so far. Not yet. I think everyone's still getting their coffee and waking up a little bit. What else? Anything else on this one?
I think like what's important, or what's the implication that NPUs are getting more important, and NPUs are usually very much tied to a specific model, that OEMs now start not selecting the hardware and the software follows. They're now turning it around, first selecting the software and then choosing from compatible hardware, because like the effort to port a model to a new NPU is just too high for them, so that they try to avoid it and really only select their ADAS system and software supplier first, and then just select the compatible hardware and chips.
Right. I see. So yeah, figuring out sort of what you're going back to almost like the first slide. What are the kind of critical scenarios you want to execute, and then getting the hardware that matches that makes sense. Okay. Yeah. So maybe we're shifting to more of a software first model here. I'm looking at a question here from Jim. Jim, we haven't talked about power consumption here. Less important for automotive, but other spaces tend to be, yes, of course. I think, in the automotive scenario, they are running on battery, but not that kind of battery. But yeah, I would say overall, like in terms of, I think probably everything that goes into an EV these days is measured on weight and power consumption, right? To extend battery life. So in as much as, we're getting more power efficient SoCs and NPUs, I guess that's going to be a competitive advantage.
Yeah, power consumption was basically selected number 2 pain point of Edge AI in automotive. I think there are typical dimensions. I think it's not just the energy consumptions. Batteries are big. There are other, let's say, domains where this is a bigger of a challenge, but I think also high energy consumptions correlates with high cooling need, potentially leads to water cooling, and that's all costs you want to avoid. The consumer,
I don't think you want to water cool your NPU in your car. That would be maybe a McLaren or something. The other thing we haven't talked about too, actually, I'll bring Marcelino's question up here. I noticed a couple weeks ago, Mercedes announced the iconic, I think it was like not yet bringing to production, but it was more of a, I don't know what they call it, a show car or whatever, but they had mentioned in there. So if people look up the Mercedes iconic, which looked beautiful, they talked about using neuromorphic computing. So in the sensors themselves in cars, which traditionally have been dumb, the sensors themselves now are going to be running AI workloads. So they were talking about using neuromorphic computing in some of the sensors of their car, so that you're not running every AI workload on this, magical NPU, that you're actually doing, even edge AI. There's multiple edges in the car moving forward, right? So you could, use that to be much more power efficient, because neuromorphic computing tends to be super power efficient relative to sort of traditional architectures. But did the survey pull that out at all, or is that more of a
no? I think we did the survey a year ago, so I think this Mercedes was not there yet. But I think it's a little bit going back and forth. I think we started with smart sensors, like early ADAS sensors were a camera with a compute in it doing everything. Then with more advanced driver assistance systems, where you need to do like fusion of different sensors, the intelligence went to a more central or zonal computer. And I think now we're getting into a hybrid world where some sensors might get AI. I've also seen it that radar's getting AI to improve the detection. And it's also a matter of like bandwidth, especially radar. Raw data is pretty big, so having some AI on a radar and then only transferring objects might make sense. So I think in the future, we will see both. I mean, still fusion on a central compute, but even smarter sensors.
Yeah, exactly. So even within the vehicle itself, there'll be several levels of edge AI running in concert, right, for efficiency. Yeah, very cool. Well, this has been super helpful. If there's any other questions, I think we're going to shift back to Danilo. We can bring him back on board here.
Yeah, thanks for having me.
But yeah, thank you so much, Martin. This is really interesting. It's always good to bring the voice of the customer into the conversation. And thank you to McKinsey for giving us your time. Sounds good. All right.
Very good.
Danilo, we're back.
And maybe I'm more fluid now.
More fluid, yes. I think that's good.
These networks play always some jokes. So
you know,
now,
the internet.
yeah. So now we are into the session 4, sensing interaction and health. And ciao Michele, welcome. Michele Magno, professor, ETH Zurich. Great to see you here and fantastic you accepted. You will talk about Generative Edge, wearables, AVs. So please, the floor is yours.
Okay, so I think now, okay, you can hear me.
Yeah.
Okay, good. So thank you very much for the kind invitation, and good afternoon, morning, or night to everybody. And thank you also for the nice introduction that bring me to directly to the point I want to present today. And actually from the previous presentation, we saw already one of the different applications that we are hoping to improve with the AI in general, Gen AI or Edge AI. This is ranging from smart health, glasses, robotics, agriculture, home, smart home, smart cities, retails, and many others. And actually, we saw also in the previous presentation the needs and the fact that this growing, emerging generative AI, or in general large models that are enabling to make it more and more smart, these applications is somehow also an issue. So in previous presentation, but also these are some things that we know. We have an exponential growing of the complexity and the memory needs for this kind of models. Often people are saying that we are optimistic because our brain can host 100 trillions of synapses as consume only 20 watts. But in this presentation, I want to start actually with some things that is a bit different, because we don't need actually to forget that these models that are comprised by parameters and memory parameters, and then are not running in our brain, but are running really on a computer platform that are done by transistors. So I think this comparison brain versus the computer in terms of power cannot be until we don't change the transistor, and actually this transistor probably will last for many more years. And also here we can see more in depth the problems, and also the fact that, I don't know if you know, but Transformers actually was designed for the fact that they find out that attention mechanism, they were at that time in 2017-18, they were very efficient in terms of memory. So you can see here in this slide that the Transformers in 2018 was taking just a fraction of the memory available in a computer platform, and today, only 5 years after, the situation is completely opposite. Actually, we need to gap the memory that we require for large model with the fact that the CPU are not scaling so fast like the memory, the modern memory requires. And why? This comes from the nature of the silicon. So I think this slide probably is well known from most of you, but is giving all the ingredient of the reason why you cannot scale so much up, and also the reason why after more than 50, 60 years, the Moore law is still there, that is telling us that we are having double, more or less, transistor per every 2 years, and not the number that can grow faster. And this means that even NVIDIA has to create processor that are advanced AI processor, means that they're exploiting the current number of transistors for specialized hardware, means that we can expect that a part of these techniques to have acceleration, AI accelerator or specialized hardware. At the end, NVIDIA techniques also cannot do miracles. Means that when we move for having a processor that are requiring or they are complete with a number of transistors that are running with a power of above 100 watts, and we move this request of power, because at the edge we don't have these 100 watts, but we usually run with 1 to 10 watts. Automatically we have a gap that you can see this arrow on the left, that we are missing even further the operation, so the peak performance in terms of memory operation per second. Of course, some people can say, okay, yeah, but we can do efficient processors, but you can see here what happened with efficient processors. You move a bit further on this line, you cannot have the GPU's performance, because automatically you are working with the same transistor, but just in small numbers. So the goal is that we would like to boost the performance. So ideally, we would like to have the same Gen AI models running today in NVIDIA. Already they're struggling to run in NVIDIA 800 platform in a processor that are consuming less. And ideally, we would like to go where the target is it. And actually, this is not possible with hardware alone. This is it's not possible, because it's physically impossible today to have processor that are consuming in the range of milliwatt of watts and are providing the same performance data center processors. So how we to do it? So essentially what is happening today is that actually software becoming more and more important to try to close this gap. And this is also some things that now seems that finally, actually, this I'm coming from embedded system, sub-physical system for 20 years. So I think it's nice that NVIDIA say that actually next generation competition is on physical AI, and we need to push both hardware and software to try to have this new challenge accomplished. And this is especially also, you see that NVIDIA is, of course, an hardware company doing processor, but is pushing more and more on making hardware. And on top of it, I think when we move to the edge, I think this I can go a bit faster, because we see a lot of interesting feature from the previous presentation, where they were saying that we can have improvement of latency, data protection. We need to go in edge when we are having the bandwidth is not enough, or we don't have connectivity, and of course we pay it in terms of power consumption, because at the edge, as I mentioned before, this is not some things that can come from magic processors. So this is interesting, because why we are also interested to go on the edge, because there are a multitude of devices that can accomplish different applications. So this is quite interesting. So how we can do it? So we always say that AGIs can confirm sensor fusion efficiently, the system level, and can reduce this latency. But this means that actually we need to change a bit our mind, or to go in some things that also take in account the benefit of moving sensor. I was very happy in previous presentation to hear that it's important also for the automotive application, having sensor, maybe radar, and other kind of sensor. Here you can see an example that, for example, moving from a RGB camera to an event-based camera, you can actually reduce the bandwidth of 100 or 1,000 times in terms of data. And also, if you then have this less data, you can have actually more freedom to have more complex algorithm that can run in a small portion of this data with the sensor fusion, with other kind of data. So I think that the sensing and the edge AI need to go together even further. This, I think we don't touch this in this presentation. Also, communication can be done in efficiency. These actually are the topics I'm doing in my group. And in particular, then also it's important to keep in mind the application. So often I have some comment from a company, also from colleagues, from academia, say, Michele, we need to put Gen AI at the edge. My first question is that what you want to do? Because edge AI, it's application specific. You cannot do a general purpose for ChatGPT on a small power processor. But we need to have the application in mind. And with this in mind, I would like also actually to bring two examples where already today we were bringing the generative AI successful on robotics, and then I will also show how we can be we were successful deploying it also on wearables. I don't know if you heard about the reinforced learning with verifiable rewarding that is emerging for having efficiency strategy to teach LLM to reasoning. This is active in robotics, and also today we more and more hear about embodied AI. That means that we are embedding the AI inside the robot, basically. This means, or an embedded system in particular. And this basically with this embodied AI, sorry, I went a bit too slow. Embodied AI agent, typically we are training them with the static data, and we are running them on the platform. But what happens if we are learning in an embedded system? So here we were trying to have training and deployment of the agent inside the machine, and actually we surprisingly, or not less surprisingly, we want to actually demonstrate that this can be an efficient way to continue to train. Actually, we showed that our model was running locally. In this case, it's not in a microcontroller. We were running on a Jetson GPUs combined with a small NUC processor, but we were overperforming GPT-4 in learning. What means overperforming in this case? Not only power here. Is overperforming means that, for example, you can see in this video here that the card you can see with more resolution is going faster, is learning how to go in this track in the faster way. The learning time is shorter, and this affects the speed of your car. So this means that in terms of security, in this case, we actually were doing an international student competition, but this embodied AI, this efficient AI is actually in this case learning faster. And also means that if you have efficient AI, you can even host more intelligent parity of the hardware. This also, I don't think we have time here. We also make the same things here. Plus, we were using depth camera, and so instead of LiDAR, we are using a small, low power and data intensive camera. We use depth camera, robust reinforcement learning to basically self-learn in this labyrinth. How move in not a flat. It's actually it's quite challenging even if you do alone. Actually, in the floor is moving and there are stairs. The robot is learning alone, and what this means again means that you can go faster or the other to win in competition. And this because I think Edge AI can be actually a strategy if done in a proper way, especially at system level, to be more efficient and also more winning. And I will close here. I think this I'm going into with another example that also this was recently presented in a Tripoli Sensor. It was nominated like the best student oral presentation award, where actually we took a sum 2 from Meta and we proposed a Pico sum 2. Of course, it's different. Basically, we could make segmentation inside, so it's in sensor segmentation inside to the EMX 500 Sony camera that is hosted DSP. So this is because I'm saying it's possible if you put the things together. Of course, here we are doing segmentation. You can see actually the segmentation is not done to all the parties, done only on the red dot we are going to see here. This segmentation, of course, can enable robotics to be more intelligent, can enable different kind of robotic application or smart glasses application. It's also interesting because we actually move down the model that this is the model from Meta. We completely change it. So we moved from a few hundred megabytes to 1.2 megabyte of memory requests. We need to change some things. We make heavily use of quantization. We use acknowledgement distillation to exploit the larger model to bring it in a picosum. You can see that actually the performance on the COCO dataset in terms of mean average precision are even not so worst, actually, in the same range of the bigger model. And then we have a model size in logarithmic scale that is wildly smaller than the mobile SAM, the tiny SAM that we are doing. We were using it. And I think I promised to say in 50 minutes. So this is the demo that show better. So we really compress it. So this is because I strongly believe today is possible with the right optimization and hardware software co-design at system level, including the application, because this segmentation can be good for one application and worst for other application. If you put the three things together, is yes possible to have generative AI and also extreme complex AI task running in a more efficient way. And with this I conclude, and I open if there is any question. I don't see the screen of the question, so I ask maybe Danilo to ask me the question, or I can remove my screen sharing. Thank you.
Thank you so much, Michele. Very interesting talk. And in the meanwhile, we wait for questions to appear in the chat. Maybe I can start with some. The first, maybe, there is a lot of examples. The most notable, it's the BitNet and some derivatives, which are trying to massively reduce the footprint of these language models, and sometimes these are represented in binary or ternary. So, do you think we need to focus as well on sensor which generate type of binary data to match this trend of binary and ternary language model?
Yeah, I think this is for sure is an opportunity. As I mentioned before, I don't think there is a magic formula to say what is the best sensor and the best processing. Depends also of the application requirement. But for sure, the combination of binary network with the binary information coming from the sensor can help the speed up of the processing. And also, it's important to notice that today also few processors are able to exploit the max, the binary. So probably also in future we will see if this model and this sensor exploiting this model or no other sensor exploiting the binary models or ternary models, if we have also the hardware platform that can accelerate this kind of model, of course this will be the let's say the direction to get. I think in general, you know me enough. I'm not religious, means that I feel the different models, the different way to process this model, different processor can be a winning solution for one or the other application. So it's good to have a different hardware and software solution to then pick up the best for the application scenario that you have in mind.
Thank you, Michele, for your great comments. In one of your earliest slides, there were these ISO curves with 10 terop per watts, and I mean, it's just a wishful thinking to imagine go beyond to 100 terop per watt, or you see a possibility to extend that?
I say the possibility comes also if I would say what a transistor can do. I think in terms of numbers per area is not scary so much. These some things that we can calculate. So I think the theoretical limit are more or less the one that are in the curves. But combining hardware and software also with the sample you mentioned, with having a binary maybe representation of the model, of course, these are the make the overall peak performance higher. If you move from float to binary, of course, this is going higher in terms of operation in binary form per watts. So these are many tricks that you can have it, but we need to remember that down there is a physical device that cannot do the miracle, because then there is an aggregation of transistors that are doing the real processing in hardware.
Yeah.
So there is some margin. Yeah.
Sorry, go ahead.
No, I think there is a margin, but again, there is no miracles.
Okay. And there is Alan, which also shared a comment or maybe a question. So we were speaking about binary, but what about preprocessing? I mean, typical approaches such as FFT can match such approaches, or these are out of the picture.
I would say a lot depends on the performance in terms also accuracy that you are expecting, because and also from the application you are using. I think I would say that in some use cases the linear representation can be the solution. In some other, you need to do an FFT in a float, for example. So I think it's hard a priori to say that there is one that is the winning solution. Depends what are your preferences, what your application requires.
And maybe one last question, Michele. In one of your latest slides, you just touched the words about quantization, pruning, knowledge distillation. Yeah. In short, to derive edge-oriented language model, do you think we have all the tools that we need to derive such parameterized neural network from what we see in Hugging Face and the like?
I think currently we are much better than a few years ago, as you know. So I will say that the tools are becoming mature to support the designer of efficient models much more than a few years ago. In general, we work very low level, so if something is missing, we are doing in our own. But I have the feeling that we are currently in a good maturity for this kind of tools. I'm more seeing the problem that is not automatized, so there is still a lot of work of experts need to do to make it. Because, for example, this optimization we did in SEM2 was taking six months from 2 people. So I think it's still the tools are there, but still you need to do a lot of manual work, evaluation to do it, training, retraining, re-evaluations. But I feel that the tools I don't see are the tools that the critical point at the moment.
Very good, Michele. Much appreciated your time and your talk and your patience to answer these few questions. Thanks a lot.
Thank you again for the invitation. It's always a pleasure to be here, and also hear very nice talks that are coming before after me.
Thanks, Michele. I really appreciate it. And now, Xiaofeng. Hi, Xiaofeng.
Hello, hey.
Nice to see you.
Nice to see you again.
Yes, we met at the Tripoli Sensor, and I'm glad to see you here again. Xiaofeng Tan is from Python, and his speech is about GenAI role in creating robust gesture models. Please, Xiaofeng, the floor is yours.
Thank you, Danilo. Hello, everyone. My name is Xiaofeng, and I'm joining you live from Boston, Massachusetts. So first, I'd like to thank Edge AI Foundation and Danilo, our chair, for this opportunity to present our work in generative AI. It's a great pleasure for me to meet you all and to be part of this session. Sorry, give me 1 second. Oh, it's moving. Okay, very cool. So I'm currently working with Python technology, where we develop neural sensing variable technology and products. In collaboration with ST Microelectronics, we created the so-called ST-ENG neural sensor, which is roughly like 2 millimeter by 2 millimeter in size, as shown in this picture over here. The ST-ENG sensor can be embedded into variable devices to measure the electroneurograph signal on the top wrist of the subject and enable a wide range of capabilities from hand gesture detection for AR, VR applications, control of smart devices such as smartphones, smart glasses, smart cars, and smart homes, to cognitive state measurement and prediction. So these cognitive insights can help you assess your readiness for demanding tasks such as sports competition, long distance driving, even interview preparation, special operations, and more. But today, I'm gonna actually focus on the role of generative AI in building robust hand gesture models. In a recent Nature paper, Meta's gesture team presented a scanning law analysis showing how gesture model performance improves with the number of participants in the training data set. As shown in this plot over here, the results make one point very clear. To develop a reliable hand gesture model, you need data from thousands of subjects. So why is so much data required? Well, there are two major reasons over here, right? So the first reason is due to the so-called cross-subject variability, which basically means that the same gesture could produce very different signal patterns across different people due to natural physiological differences among different people. And number two, due to the so-called cross-section variability. This basically means that even for the same person, the data patterns of the same gesture could look quite different across different data collection sessions because of factors such as electrode placement, skin electrode contact, sweat, motion artifacts, change of neurologic environment of the human body, and the environmental EMI. So many factors could actually change the data patterns collected in a specific physical session. So this poses a major challenge for small teams because data collection in general is very expensive and slow. Researchers have explored many mitigations such as data augmentation, domain adaptation, transfer learning, and synthetic data generation through generative AI. So today we are actually going to focus specifically on how synthetic data generation using generative AI could help overcome, at least partially overcome, this data scarcity issue in gesture modeling. So at Python, we evaluated two major generative AI architectures for generating multi-model ENG IMU data for gesture modeling. The first type of models are GANs, generative adversary neural networks. And the second type of models we evaluated based on diffusion models. From our experiments, we found that diffusion models in general tend to be more effective and reliable than GANs for gesture modeling. So in the next few slides, I'm going to share examples how two different diffusion models can improve hand gesture performance from our study. The first model is the so-called diffusion TS. which is a model developed by a team at Hefei University in China, specifically designed for time series generation. The second model is NeuroForge, which is an in-house diffusion model that we developed at Python for multi-model ENG-IMU data generation to support robust gesture modeling. So this slide shows an example frame of raw ENG-IMU data for our Python 03 device generated by the NeuroForge model. Each frame or data frame contains 8 channels of 600 consecutive sensor samples. The first 2 channels are the ENG data. The next 3 are the ACC data. And the rest 3 are the gyro data. So for our gesture models, we actually use, all those 3 different types of sensor data to classify different gestures. And this slide show the TSNE visualizations of example sensor data generated by the diffusion TS model. The first row displays data frames for 3 gesture classes from experiment. So each class represents a unique subject gesture combination. And each dot, each point that you see over here represent, a data frame which consisted of 8 by 600 data points, basically. So the red points denote real data frames collected from the experiment. And the blue dots or blue points denote synthetic data generated from the diffusion TS model. On the second row, the red panel shows all real data frames from the experiment. And the left panel shows synthetically generated data with the diffusion TS model. Roughly 10x more data than the data frames shown in the real set on the red panel. And this slide shows similar visualizations of example sensor data generated with our NeuroForge model, comparable to those on the previous slide. As you probably have noticed, hopefully, NeuroForge model produces data that more closely resemble, the real samples. So this is evident from the first row plots. If you compare the sizes of the red versus blue clusters for the 3 gesture classes, you would notice that the NeuroForge model produced clusters are more consistent with the real data than those produced by the diffusion TS model. This observation is also supported by, a calculation of the so-called context FID scores for all the gesture classes of data collected in the experiment. Context FID is basically a distance matrix that evaluates how closely the generated data follow the distribution of the real data in a learned context latent space. So lower context FID scores indicate, the synthetic data more accurately replicate the characteristic of the real data. So as you can tell from this plot that the red bars, which, are produced from the diffusion TS model, are consistently higher, the blue bars that were calculated from the neural forge model. So basically telling us the same thing. The neural forge model produce more accurate data in the synthetic data generation, basically. So with both, the real and the generated data, we conducted a comparative study to evaluate how synthetic data can improve model performance. This slide basically shows the number of data frames in the original training data set shown on the left, compared with the augmented training data set that combines original samples with synthetic ones, shown on the right panel over here. So for this analysis, we excluded the inactive data and build models owning the double tap or two tap shown in the plot over here, double tap, money, and the rest gesture classes. Okay, so these are the results of the different models. So we basically trained 3 models, one on real data only, one on real plus diffusion TS generated data, and one on real plus neural forge generated data. So all 3 used the same architecture and were tested based on a test set that were collected in a completely separate session that the model, none of the model had never seen. So this is what we call within subject across session benchmark, meaning that the same subject appear in both the training and the testing sets, but the training and the testing sets come from different physical recording sessions. So the results are very clear. The real only model reached roughly 95% accuracy. The diffusion TS augmented model reached like 98.6% accuracy, and the neural forge augmented data reached 98.8% accuracy. So as you can tell, adding synthetic data alone cuts the error rate of the the real data only model by roughly 70%. With neural forge model giving a small edge over the diffusion TS model. So here are some, I guess, high-level takeaways. Number one, we found that generative AI is very useful in gesture modeling. Basically, it fundamentally shifts, the deep learning of, gesture models, enable it to move away from, reliance on massive, costly real data collection. And number two, we found that diffusion models are really powerful, in synthetic data generation for multi-model sensor data generation. There are some challenges as we can tell from our study. So number one, developing generative models that can accurately represent, the full variability of real-world human physiology remains very challenging. So far, our models prove that, generative AI models could be really useful to actually improve the so-called within subject cross-section model performance, but we have not actually succeeded in doing so to improve the so-called cross-subject model performance. That's going to be our next target. So number two, drastically reducing computational complexity of edge AI. Complexity of the generative AI models for low-end computational device is still very challenging. So we hope that in the near future, we could actually achieve good performance of our models, on low-end system and even maybe on edge AI devices. I guess that's it. Thank you very much for your attention.
Thanks so much, Xiaofeng. It was very interesting because you touched the point regarding the data sets. And I remember that 80–90% of the project time in machine learning can be easily spent on data set acquisition, population, and conditioning. And so that's a huge point of attention for who develop workloads. And now that we have generative AI workloads with billions parameters at the edge, clearly these exacerbate the challenge. But here the point, maybe you can comment as you wish, Xiaofeng. So, I understand it's important to automatize data generation and take advantage of diffusion models or the like. Clearly, this is clear. But imagine that I wear this device. So this device is mine and should understand my data. Okay. And obviously, it's difficult to me to obey to a protocol where I should get data as a normal person. I mean, not as a technical guy in the field. As a normal person, I don't want to be bothered with data acquisition. I don't calibrate even the gyroscope in my smartphone. So it's too complex. I don't want to do that. So I want something that fits my data. And obviously, I don't want to deal with data population in the data set, but still I pretend the approach at the edge is accurate. So, and maybe, there is not only the point of data generation, which fit my habits, my purpose, and my needs. But also, maybe you want to use that to feed a neural architecture search approach to automatically design the network. So, all in one, how can objectively trust data generated in the way you presented? Any comments on that?
So I guess this is a really good question. We have two major applications of our sensor. Number one, gesture classification. Number two, maybe cognitive, state prediction and measurement. So I think for gesture classification, in order to make the model, accurate, we, at least for now, we have to follow very well-controlled protocols of performing, gestures, because that, there's so many different ways of performing gestures, even like, for example, for this so-called, I'm not sure if you can see it, for this so-called money gesture, different people perform it slightly different or maybe significantly differently. So that, if we don't, well control, the data collection, the model performance is going to be different, because essentially, some subject may be performing partially different, maybe completely different gesture. Oops, sorry. Am I lost?
Hello, Xiaofeng.
Yeah, am I still online? Okay, I don't see myself, but okay. So the second, I guess, application is a cognitive state prediction. For that, actually, something that running on the edge to generate data that mimics, the signal patterns would be actually quite useful. Because, for that type of application, you want to capture, raw data patterns without, tightly control, the behavior of the subject. Yeah, I'm not sure whether I actually addressed your question 100%.
Maybe we can take it offline, Xiaofeng, but thanks to comment, I think the topic is super interesting, and maybe we need to deepen in it offline. Xiaofeng, thanks a lot for your time, for your great presentation and talk and availability. Really appreciated. And sorry, now it's time to move to the next speaker. Ritik and Anusha Brainchip will welcome Ritik, and you will speak about attenuate real-time audio denoising. Please, the floor is yours.
Hey, thank you very much. Just a second. Hey everyone, I'm Ritik Srivastava, Solutions Architect at Brainchip, and really excited to be invited to give this talk. And in my current talk, we are going to explore how state-space models enable efficient generative AI on edge. Now, for Gen AI on edge, efficiency is the real differentiator, and efficiency depends on power, latency, and memory bottlenecks, and that's where Brainchip stands apart. Now, on this slide, you can see a normalized efficiency measure, which is tokens per second per watt per billion parameters. So what exactly does that mean? So it's a measure of generative efficiency, how fast a model produces tokens for each unit of power and model size. So this basically combines speed, power use, and model size into one normalized number for fair comparison among the models. And what exactly does that mean? So the higher value of the number means the model is significantly more efficient, which basically corresponds to delivering faster generation with lower energy cost at scale. So now if you look at both the sides on the left and right, you'll see when you compare that Brainchip 10's SSM LLM on Akida achieves really high efficiency. It's not just better, but it's basically orders of magnitude higher than typical transformer-based solution on edge. Now, why exactly we have chosen Qwen? It's because Qwen on Raspberry Pi as a baseline. So that's because Qwen in that scale is a state-of-the-art transformer LLM, and Raspberry Pi represents a typical low-power edge device. So this comparison actually gives a really significant insight because this shows that higher efficiency number enables real-time generative AI within strict power and memory limits. And this is made possible at Brainchip by the work which we do while developing hardware and software co-design, and also while optimizing the state-space models for the edge constraints. Now, before going into the technical details or technical nitty-gritty, I would like to give a snapshot of what Brainchip does and what we focus on. So we are the worldwide leader in neuromorphic AI. And coming to the research specifically around SSM, so the basis of SSM came around 2019 when LUM paper was introduced, which first time came up with linear time invariant state-space model concepts. And Brainchip has been doing cutting-edge research in this direction around SSMs and dynamical systems AI from around 2020, when Stanford and CMU started research on this thing. Most of the industry has been focusing more on optimizing the SSM models for GPUs, but Brainchip has been creating and optimizing SSMs on edge. In terms of our offering, we provide silicon, IP, and solutions, and even the model zoo and software stack to power Gen AI on edge. And to enable the kind of solutions we provide, like LLM enabling for edge devices, and also voice assistant, which has voice-to-voice pipeline, including ASR, LLM, TTS kind of models, basically. Okay, so I have been talking about SSMs like since the start of my talk, but what exactly is SSMs? So SSMs come from control theory, and in an easy way, we can say that it's a type of recurrent neural network, RNN, which can be trained like how CNNs can be trained, and during inference it can be run like how RNNs usually run. So how exactly does that make a difference, or how exactly that helps? So one of the major problem with RNNs while in training has been that it's hard to scale RNN, or it's hard to use the parallelization of GPUs while you're training the RNNs. And also in deeper networks, they go through vanishing gradient problem, which makes the training of RNN unstable. And because state space models can be trained like how CNNs can be trained, so that eliminates the training problem. Now, for inference, in case of convolution networks, to capture the long context properly, the CNN needs to have higher number of parameters, and on edge devices, that's not really feasible. So that's where SSM recurrent mode inference comes into play. That it can run how RNNs run, which is having a constant state or memory which keeps on getting updated with each and every timestamp. That helps with efficient inference while you're running any AI workload on edge device. Now, going to one of the things which was mentioned in this session initially, that recently memory bandwidth has been a major factor than compute. So power is a major metric for AI on the edge, and energy isn't just about the compute, but also about the memory movement. AI compute has changed a lot recently, especially with Gen AI incoming. So initially, with CNNs, each parameter was involved in multiple computations. So usually the AI workloads used to be more compute bound. For generative AI, which recently used transformers or SSM, generally each parameter corresponds to a single computation, and that means the problem is now more memory bound. What exactly that means is supplying data to the compute engine becomes a bigger problem than the compute capacity itself. Now, when you're running an AI workload on hardware, ideally storing all parameters in SRAM would consume the least energy, but that's not exactly feasible. We cannot have large SRAM. So we rely on flash or DDR. In case of transformers, you need to store weights, and with every incoming token, the growing KV cache requires a lot of writes. That conflicts with the flash technology and forces DDR, which consumes higher power. That you see the lower part of this diagram. Now, with SSM, things are a bit different. They have a constant size state that doesn't change with the new tokens. So there is no KV cache involved there. Since the state is constant size and small, it can be stored in SRAM, and with no KV cache writes, weights can stay in flash. This basically reduces the memory movement and overall lowers the system power consumptions by a lot. Now, this slide gives a bit more granular visual understanding of what we discussed in the previous slide, which is in case of transformers, with each and every incoming token, you can see that the KV cache keeps on increasing. That means that the constant writes and reads creates heavy memory traffic and high power consumption, especially when off-chip DRAM is involved. Whereas if you see a SSM, here we have a constant size state, which can be small enough to store in a SRAM, and this means that fewer memory transfer, no KV cache overhead, and this provides ability to keep the weights in flash and state in SRAM. This results in dramatically lower energy use and provides better efficiency for edge device when you are actually running AI workloads on the edge. Now, on the right side, you see a diagram which basically shows how SSM works, which is basically how RNNs work. Here we have our previous hidden state, which is used with the input to get the new updated hidden state for current timestamp. And then that state is used to get the new output. So basically, this is the normal SSM equation. And other pro point of SSMs against transformers is that in terms of computation, usually transformers is higher than having linear complexity. Initially, it used to be quadratic, but recently there have been new advancements with flash attention and different kind of attention mechanisms where people have been able to reduce that computation, but still it's more than linear usually. In state space model, that's not the case. It's always linear with constant state size, and that's how also you get compute efficiency over there. Okay, so these are some intrinsic properties which makes SSM better than transformers for edge. But at BrainChip, we have been working on further innovation in this direction. And one of that is precog, which is basically used to reduce the preload problem in RAG. So RAG, retrieval augmented generation, is basically a type of you can say mechanism in which basically based on a new user query, retrieval of external information is done, which is then combined with the query to generate the accurate answers by LLM. Now, the challenge here is that every query requires processing of the retrieved document along with the query, and that adds latency and also increases the memory demand. Now, with precog, what we do is that instead of storing the document embeddings, we basically pre-compute the hidden states of our SSM model based on the documents and then store those hidden states. So whenever a new user query comes, instead of those embedding, we retrieve the hidden states and fuse it with the already existing hidden states of our model and then do the auto-regressive generation. How exactly that helps is because the documents have already been ingested in the form of hidden state. That makes the context ingestion instantaneous and reduces the memory requirement also. And because this approach is super lightweight, it enables RAG applications on edge devices like smart refrigerator system for question answering from its user manual, or just making any intelligent interaction possible with any device. Then second innovation here is our proprietary compression algorithm, where you can see that like here we have trained a 24 layers SSM model, 1.1 billion parameter model on pile dataset, and then slim pajama dataset, and then we are evaluating it on pile. Now here the perplexity score basically corresponds to the amount of confusion that the model is having while predicting the next token. So higher is the perplexity, the more model is confused while it is predicting the token. So in ideal case, for a model to be better performing, the perplexity should be lowest possible. Now here you see that in FP32, our perplexity score is 6.35. And when we are compressing it to 8-bit, the degradation is literally 0%. And even if when we are compressing it to 4-bit, the degradation is less than 1%. So the thing to notice here is that even by reducing the model size by 8-fold, we are just getting a fraction of degradation in performance. And that means that you can reduce the memory movement while working the AI workloads on edge while keeping the accuracy intact. And that's really substantial achievement here. Now here, what's important here is that this trend isn't just coming from BrainChip, but that's a broader consensus coming across both research and industry, that the state-space models are providing to be more efficient than transformers for many edge applications. So here are like various models, which is RedNet, Mamba, Jamba, S4, various papers which come to the same conclusion, which is SSMs are performing better than transformers in different possible ways. Now, why is that? That's because the SSM model perform either better or same to the transformer, but while using much lesser number of parameter in comparison to their transformer counterparts. So because the number of parameter involved are also less, that reduces the memory movement and hence reduces the power consumption too. So the major takeaway here is that SSMs aren't just an alternative, but they are actually becoming preferred choice for scenarios where efficiency, scalability, and real-time performance matter. Now, this basically shows how our LLM is going to run on our silicon. So here we have our 1.2 billion model SSM running fully on silicon. It's 24-layer SSM architecture. It's trained on Slim Pajama, which is an open source dataset. That means that if an end user or customer wants to take our model, train or fine tune it on open source data set, they'll be able to achieve similar kind of performance. We haven't trained any proprietary or custom data set for this, which helped us to reach that performance. So any customer can just pick up the model and enable their usage, basically, their use case, basically. The context length here is 2048. The design specs which we have considered here are 1 gigahertz operating frequency. We are going to use flash because SSMs enables us to use that. No DDR, that helps us to reduce the power consumption further. And here we have considered 64 Mach engine. So these are our current design considerations, but based on the customer requirements, whenever the customer comes to us, we usually discuss about their use case and their performance goals, and we are flexible in changing these hardware requirements to as per that. For 1 gigahertz frequency and 64 Mach, the tokens per second generation you get is 46, streaming in autoregressive mode. Now here, this shows our demo of our 1 billion parameter model running on FPGA. So basically, here we type a question, and this FPGA is running at 120 megahertz frequency. And that's why the tokens per second is around 5.5. But in the silicon, it's going to be 1 gigahertz, and hence the tokens are going to be around 46. Now, here you see that the second question is being typed. And the major takeaway from here is that it remembers what exactly was the previous conversation in the form of state. And when it answers the second question, it takes that context in account and then answers it, basically. So in Alexa or various applications, that's not enabled. So using this kind of technology on edge, you can have chat application for interacting with your edge device, basically. Okay, so now we have seen that BrainChip is enabling real-time generative AI with ultra-low power and memory footprint, and how state space models are better suited than transformers for these kind of edge scenarios. Our ongoing research and innovation are driving new capabilities, and we are opening access to TENS models soon. This means that you can start experimenting, training, and contributing to the ecosystem. And if you are interested in making devices smarter, more efficient, and truly independent of cloud, we invite you to connect with us. You can scan the QR code, sign into our developer website, and apply for the early access for these TENS models. That's all. Thank you.
Thank you so much, Ritik. Very, very interesting. Maybe there is time for a quick question. You mentioned in a part of your presentation that with language models and we had to optimize the memory path, the memory hierarchy, and these are dominated with respect to the computational complexity. But now reasoning is coming into the picture. So can you share some comments about the balance and how your architectures and approaches can deal with reasoning?
Yeah, sure. Basically, that one of the diagram which kind of gave an insight around this particular topic was that in case of, like, previously when AI workloads used to be more like CNN models, you have a small size kernel which basically is involved in multiple computes. So there you need to have better compute engine to get better efficiency from the model. So a single parameter is involved in multiple computes there, and then it becomes more compute bound. In our case, or not in our case, more in generative AI use cases, now because we are using transformers or SSM, which are like big number of parameters in billions, basically, we are not talking in thousands or something. That's where the major problem is, that the compute engine is sufficient, but the data supply to that compute engine is not that sufficient. And that becomes a major bottleneck in improving the efficiency of the model. And the power requirement basically is governed by both compute and also the memory movement, especially when you are using off-chip storage. So that's what we are trying to optimize on here by using SSMs. That first of all, eliminate DRAM, we can use flash, and no KV cache involved with SSM. So that also reduces the memory movement there, which basically helps you to improve the efficiency of the model while running the generative AI workloads.
Thank you so much. Thank you very much, Ritik, for your time to answer these questions. There is maybe a quick question from a person. If essentially is asking if you can comment also other use cases rather than only LLM.
Yeah, sure. So we have been using SSMs in multiple use cases, including like medical, audio. And initially, I also mentioned that we are also working on conversational AI, voice to voice system where it involves ASR, TTS, LLM. So SSMs are efficient in it's basically efficient for any time series data, one dimensional data also. And in audio, we have done a lot of research. We also have a research paper Attenuate, which has been published in Interspeech, where we process audio data without any MFCC or STFT, like direct raw audio is used. And because in those kind of use cases, the sampling rate is much higher, so SSMs makes the solution much better, also much more efficient. So it can be used in various modalities and works like a charm on Edge.
Thank you so much. I think we can stop here. Grateful for your time and attendance and contributions.
Thank you.
Time to move to Giovanni Scapellato, ST Microelectronics. Ciao Giovanni. And the title of your presentation is Gen AI for Biosensor and Cardio, and the floor is yours.
Thank you. Hello to all. I'm Giovanni Scapellato, as shared by Danilo. I work in ST Microelectronics, and I'm really excited to present today. And I want to thank you, the Edge AI Foundation, to allow me to present this work on Gen AI applied to biosensor. So. Let's start with the why. So why we did this work. Basically, we have seen with the healthcare 5.0 a patient-centric shift. So the idea is that is not anymore hospital-centric system where the patient go to the hospital to do the exam, but there is a focus to shift the focus to the patient, and with the new technology and the biosensor that are more and more powerful, we see that this can now be done really in this shift. And then there is a disruptive technology now that is the generative AI. So our idea was to take these three axes together and see how, with the generative AI, the biosensor, and this patient-centric shift, we can improve the user experience, the accuracy, and reliable of cardiac diagnostic in this new century. So what we did, we tried to we created a chatbot solution based on ST biosensor. So there are two biosensors, the ST1 VAFE 3BX and the 6AX. And today, what I'm going to present is the methodology framework that we used to have a chatbot. So you can imagine a chatbot in front of your patient or the doctor or whatever you want, where you can exchange, interact with your language and take diagnosis or suggestion or whatever you want based on the data that was extracted from the biosensor. Then I will go and present some evaluation about the metrics and what we achieved with this approach. So what is our methodological framework, the workflow that we used in this work? So of course, the step one is related to the data collection. So we captured the data from the sensor, and we then move to the step two, that is preprocessing. This is very important, and I will spend more time on this part because the preprocessing was the key of success of our experiment. The step three was the prompt design. So taking the data from the preprocessing, we created and designed a specific prompt that then shared to the LLM system, generate the diagnosis and provide the intelligent insight supporting the clinical decision, or be able to reply to the question to the patient. But let's focus on step two and step three, that we can call is called the context engineer. Why am I focusing this? Because initially we skipped the step two, and we tried to achieve some result taking the data and work only with the prompt. But this, after several trials with also several models, didn't give to us any good result. Instead, the context engineer refer to design and structuring the information, where the information come, of course, from the sensor, in a way that the LLM can interpret and can provide good results. And especially what was the key factor was the preprocessing. And then taking this data from the preprocessing and design the prompt taking only this data, we were able to achieve very good result. But let's go to the data collection. How we did this experiment? Basically, we extracted the data from the skin patch that we built, and in particular, what we took was 100 of ECG recording of 10 seconds each. What we did is that we, to validate and to test our approach, we annotated this data, and in particular, we took 10 type of rhythming class. So from the 100 of ECG, we selected 10 with normal cardio rhythm, 10 with atrial fibrillation, 10 with atrial tachycardia, etc., etc. So 10 class, 10 class, and 10 ECG for each class. Then we did the preprocessing. What in particular? What was what is the preprocessing? Basically, we used a NeuroKit 2 library. It's a Python library that is able to analyze the physiological signal processing, and are able to extract, especially for the ECG, some particular and in particular data that are specific and extremely important for the ECG. And in particular, we extracted the PQRST peak, and also we measure the interval PR, QRS, QT interval, and these are the key factors for the ECG morphology. Then, taking this data, we put into the next step, that is the prompt design. We did this experimentation with the GPT-4, and we created a prompt that took the data for the preprocessing, put in a prompt, and asking specifically some question to the LLM. So, and the factor that changed our result was this to add this context engineering, and so this additional metadata. And what you can think for also what we can think for the future is to increase the number of data that we put, for example, adding not only the data related to a particular ECG that was extracted at a particular moment, but also all the historical data for a particular patient. So this will allow also to personalize really the answer for this particular patient. Putting all of this data to the LLM and designing a rule-based prompt to really focus on the answer that we expect, we have seen, and I will show in a moment, that the chatbot provided immediately the diagnosis, and what was really for us very interesting was the capability of the chatbot, where the patient or the doctor can interact and can get additional information specific to the context that we shared with the LLM. So, how was the system integration? Of course, we in our experimentation we tried with as device we use a laptop where we used the as a GenAI was LLM GPT 4.0 as I said before, as a biosensor the ST1 VAF6A, and as a skin patch the STDES ESP01, that is the reference board. So when the patch took the result, this was displayed here in the monitor, and then after the preprocessing that was very fast, it shared immediately the diagnosis, and then the user were able to interact and ask additional questions in the chatbot. This was really a chatbot like you can see in ChatGPT if you connect. What was the result of our experiment? So, as I said at the beginning, our experiment was conducted with 100 of ECG of 10 different cardiac rhythmic, and what we achieved as was a very high performance for some rhythm, and F1 score of 100%, in particular for certain characteristics like ventricular tachycardia, atrioventricular block, and junctional tachycardia. We had some moderate performance with F1 score between 80 and 90% for normal rhythm, atrial fibrillation, and atrial tachycardia. And in reality, our work didn't work well for a few particular cases for hyperkalemia and hypokalemia. In this, we have basically no score, zero score in this case. And if we go to the confusion matrix, we see that for some we have a very good result, for some good, but for these two no. But our interest was to validate the approach and see really what we see as a disruption, in the way the user can interact with this device. Some additional prompt design has to be done in order to seek to increase the result. Consider that we didn't do any training, any model. We use the standard model, and we just work in the context. So we believe that improve the context, we will be able also to improve this data. As a conclusion, so integrated with the GenAI with the advanced biosensor show for us a great potentiality, really to enhance the user experience in the healthcare 5.0. Our experiment were conducted in a controlled laboratory, but what is our plan and our area of research is to improve the framework to enhance the current feature, but adding also alert capability and suggest healthcare plan, and create also script, of course, supervised script that can be executed directly in the patch in order to monitor specific health problems. And finally, also the last step is to add historical data in order to improve also the answer that then do not become generic but become specific for a particular patient. And that's all for me.
Please show me. Okay. Thanks a lot, Giovanni, for your really interesting presentation. We have a question from Brenda, and Brenda is saying, nice work and very interesting. Giovanni, passing the ECG features as context to LM is a great idea. In your experiment, is it better to pass more extracted feature or less? And then would adding a simple machine learning model, ECG classification, and pass its output, classification and score as context help? So
yes, for me, for us, yes. In our experiment, we used the data that I shared, and with less data on what we passed, we see not that the answer was not good. Having an ECG classification on top, we believe could be even better. We didn't experiment at the moment, but is also one of the topic that we wanted to manage in the next version of our experiment. But yes, absolutely yes.
And Luigi, what are the next evolutions of this project, if you can share?
Giovanni.
Sorry, Giovanni.
Yes.
Apologize.
No problem. It's because we know the list of people that have to present, and
I confused them with another speaker.
Yes.
Sorry, Giovanni.
No problem, Danilo. Okay. First of all, we want to improve, as I shared, we want to improve the quality of the result. Okay. Then second is to add something personalized for the patient. So we have some idea in mind, because as you know, classifying data that are generic is even simple, no? But the real game changer is when you are able to have a specific answer for a specific patient.
And maybe another thing, Giovanni, Many LM are evolving into agents and with reasoning capability. Do you think such capability could be helpful to increase the level of the interaction with who pose the questions?
We believe yes. There are some also activity that we are in our backlog, and we believe yes that this technology will allow, especially also for the customization that you eventually can do in to the device.
Very good. Thanks so much, Giovanni, for first of all for having presented your activity here and to accept this time to present and to answer some questions. Thanks a lot. I see Davis and Iram.
Hello.
To switch. So, ciao, Davis. Ciao, Iram.
Ciao, Danilo. Hello.
Very good to see you.
Can hear us. Likewise. Thanks for having us, and then thank you. We made it to the 4th version, so let's do this.
Yeah, so that's great. And all the story started with you chairing the first forum.
Indeed.
Sorry. Say.
Oh no, I'm just about to share the screen. Here I did put on the audio, so we should have the additional.
Oh, great.
Before you start,
yes, please. Sorry,
Davis. Let me say that we just with Giovanni Scappellato ended the session 4, Sensing, Interaction and Health, and we are moving into the session 5, Endpoints, Industrial and Ecosystem. And you are the first speaker about Industrial Edge, old meets new. So the floor is yours.
Fantastic. Thank you. Before we get into it, I assume you can see the slides. Someone can confirm?
Yes.
Excellent. I see. Okay, well, let's do this. We only have 25 minutes here, so I hopefully will make the best use of the time. It's always a pleasure to be part of these live streams, and thank you to the host and other presenters. Let's get into it. So my name is Davis Sawyer. I'm AI Product Marketing Manager at NXP. I'm also the co-chair of the Edge AI Foundation's industry, formerly Blueprints work group, where we focus on making this stuff real. And today I'm joined by Hiram. Do you want to introduce yourself quickly?
Yeah, real quick. Right. So my name is Hiram. I'm a senior AI research engineer. Very much involved in most topics from neural network vision to agentic AI. So yeah, happy to be here.
Sorry, Davis. I think you have to mute or something while Hiram is speaking.
Oh, okay.
Otherwise, you're double.
Okay. Well, we're not going to speak at the same time, so it should be it should be easy. Thanks, Rosina. So yeah. Thank you, Hiram. Thanks, Rosina. So I'll just let everyone know the slides will start very pretty. They're very marketing. Then they'll get a little less pretty. But then fortunately, Hiram's going to show some demos at the end that'll, I think, maintain the aesthetic and most of all show some cool stuff. So, I mean, why are we here and why is this so important? I mean, it's a well discussed and well known fact for the practitioners in this space. But I think to put some context on it, and apologies to those who saw NXP's Computex keynote because some of this stuff will be reused from some of these days, but it's just an insurmountable amount of data, right? That is really the lifeblood of what we do here, and that's why AI has risen to, to such popularity and prominence. But there's a caveat to that, right? It's not just the volume; it's really the bandwidth. And so with this, unprecedented amount of data creation, we need at least, depending how you slice it, 1,000 times more bandwidth is needed. Really, the rub is that our physical world is too vast to be uploaded to the cloud alone. And I think this makes sense intuitively, right? When you think of autonomous driving and just the amount of high-res video that needs to be stored, let alone, the vast amounts of information we experience as people in our own days, and then the information we create as well online with interactions, etc. And so I think we're at a crucial point as an industry, and NXP has, taken a leading position in ushering in this new era of physical AI, as it's been called, right? So the intelligent edge is where that data meets the physical world, and having the processing to not just perceive, generate, but act over it is becoming realistic. And so I think it's kind of a nice story that a few of us have also kind of shared, where we're not just perceiving, or even not just generating now. We have evolved to a state of agentic status or state with what we can achieve with AI today. And so I don't want to steal the thunder here. I'm just going to show some very powerful agentic factory automation that is not just a slide where it exists and is being shown to customers and soon is going to enter the real world. But this is I think a nice way to portray the point that we've all kind of become familiar with. Now, what you might not be familiar with is just how broad the edge is in terms of the compute and product and sensing demand. So I actually didn't know this fully until I saw the slide, but we have over 3,000 products that span the lowest end, most efficient, low form factor, low physical presence, on the MCU side, which has some memory, still has security, of course, that can't be understated, still has the connectivity, and that spans all the way up to the application processors, which, being realistic, is where most of the agentic stuff and most of the generative stuff is happening today. I don't want to discredit a future where there is, and I think some other folks here are talking about what can be achieved on MCU level, but for the purpose of this presentation, we are going to look more at the application processor side, and also the NPUs, of course. Can't have AI without NPUs. And I did say it can't be understated because security is not an afterthought. It's an essential part of not just our legacy and pedigree at NXP, but I think what a successful agentic AI deployment looks like. And so with that said, I don't want to get into all the nuances here, but there's definitely a lot of meat on the bone when it comes to security with NXP processors. The real exciting part, I think, is something that's relatively new, which is the combination of our applications processors, our connectivity, our security, with just really raw, powerful, efficient AI computing. And that is, of course, by way of the ARA discrete NPUs, which are really key to accelerating NXP's path to edge AI leadership. And so I'm sure some people are curious about what this actually looks like now that they're now officially part of the NXP family. And I think this is one way to look at it here. So they have products. Their products are the ones that are in market are ARA1 and ARA2. We are going to focus on the ARA2, just given the generation and given its fit for what the compute profile or workload looks like for something like an agentic stack. So, and I'll let Hiram give a little bit more color on that as we get there. And it's not just about the silicon, of course, as we know. It's about the software. It's about differentiated software enablement, easy to use software enablement. And this is a continuously evolving story. Like the IP under the compute blocks themselves on the left-hand side, we're always evolving how we enable our customers, right? And so some might be familiar with the EIQ toolkit, some might be familiar with Time Series Studio. Model Creator is relatively new, and GenAI Flow is a building block or a set of building blocks that help conversational interfaces, et cetera, be built. But this isn't a product pitch. I'm just setting up a bit of the groundwork because it'll be relevant to what Hiram's going to show in a moment. So I mean, as the title implies, all this stuff is, it's entering older industries that have been around since the economy. But what we're trying to understand here and then kind of dissect a bit, and a little bit of this also, I think, not philosophical, but meant for creative, spark, I guess, around, are we really just making things faster, less waste, more efficient, or are we at a point in the AI and human story where we're doing things that are like kind of new? And I think that's what we're going to try to put forward to the audience today around, okay, with this precedent or with this supposed precedent, what can we do? And I think the real limiting factor there becomes human creativity. And so why I paused here is GenAI Flow has been released now for just over 6 months. It's been really well received by our customers in healthcare and industrial and in smart appliances, but it doesn't stop there. And I think why I mention that is because even just in 6 months, we've already evolved into agentic state. I'll have to move a little bit faster because we only have a little bit of time here. But so okay, GenAI Flow is a precursor for things like VLMs and VLAs. Why? Well, we had to get a baseline for what performance looks like. I won't go through this whole demo video because Hiram is a better one shortly after. But I wanted to set up, especially this side of the diagram here. So it's a relatively small model, 500 million parameters. I think I heard Pete throw out the number yesterday that around 1 billion parameters is about 1 gigabyte of DRAM at integer 8. So keep that in mind. And this performance, it's okay. I wouldn't say it's great, but it's okay. You'll also notice that the small models have some quality errors too. And so why this is important is we've rapidly moved from Gen AI flow that was conversational into Gen AI flow that was agentic. And so there's other initiatives that are coming up in NXP that I think are going to be really exciting into 2026. But what we're trying to put forward here is, okay, with these new building blocks and with these agentic frameworks, what can we do that really does move the needle for our customers in industrial, as the title of the talk implies? And I think one thing that's subtle but very powerful is that prompts to robot or prompt to action. You can actually, without having to do vendor-specific programming or any programming at all, really, get robots or things to do things in the physical world easier than ever. And I think that will start to have second order and tertiary effects on the industrial edge. So this will all be recorded and put online too if you want to look at it later. I know we're moving a little bit fast here, but this is basically the paradigm in which we want to introduce the intelligent of agentic systems to the edge. Again, I won't go fully into the video here because I think it's important that Hiram shows his stuff shortly. So what I'll do here just to wrap up is, okay, we set the stage for potentially a new paradigm in Edge AI. What does that mean? Well, I think we're all still figuring it out. What can you do about it? Well, a quick call to action. You can definitely get your hands dirty and start building stuff. I think that's really one of the most effective ways to try and pioneer and see what's possible. So I'll put this here for those who want to or haven't already, played with Gen AI at the edge, because it's real, and you can do it on NXP. And then I'll pause here with a slightly newer initiative, which is not really specific to tools or models, but the ever-evolving stack, right? And so for those that missed it, PyTorch quietly dropped their ExecuTorch framework, which is now supported on NXP's MPUs, and all this kind of combines into what we think is a complete or a comprehensive suite of silicon software that lets really smart people do really cool, powerful stuff. So that's all my kind of product marketing stuff. I'll pass it off to you here, Hiram, to take it home, and just let me know when to move the slides.
Yeah, thanks a lot, Davis. Can you try cue the meeting? Okay. I think that should be better. Is there still echo or not?
Yes, there's an echo when you speak.
Oh, that's odd. Okay, so hear me? Yeah. All right. So maybe the question here is like, yes, Rosina? Okay, then just continue. So right, maybe the question is, where are we going with?
There is still an echo. I don't know if that's only for me or yeah. Danilo, do you also hear echo?
I hear an echo, and also you, Rosina, are echoing.
Yeah, I don't know what's going on.
Yeah, this is very odd. Should we try and continue or?
Yeah, I was muted. Let's continue, Hiram. This is why we need better audio AI. So.
Right. So let me just continue. So as I was saying, we're basically where we're going with AI is, as you know, we are working with perception AI, and really what we see there in these applications, for example, things like.
I'm sorry.
Yeah.
We can't hear. I don't think even in the comment section everyone says it's an echo. Can you maybe switch to an other mic or audio? Please.
Let me give it.
Please.
Yeah, Hiram, if you want to change.
No stress.
Yeah. Okay. Yeah. Well, actually,
we
we have 2 slots now, so we can take 45 minutes, right? Because we. No, I'm kidding.
Yeah.
Okay, yeah, my audio is coming through.
Yours is fine, but yeah, here I don't know.
Okay, we'll give it another shot.
It is a little bit off because the echo is still on, right?
Point is that also you, Rosina, are echoing.
Dave, is your video on?
Yeah.
Perhaps
Okay.
if you want, maybe you can do it if yours doesn't have an echo.
Okay. All right. We'll do that. And we'll keep you in backup for the expert questions. So, oh shoot, I didn't really have a ton of time to look over your slides. So, okay. The agentic AI that we're building, it inherently incorporates multimodality, and I think what we're going to try to walk through here is, how does this actually be implemented? And I might lean on you a little bit here, Em, if I miss any details, but I think most of us are familiar with the trade-offs between more and less autonomy and what kind of controls versus templates you can take to execute this stuff. But really, it's this paradigm of sense, think, and act. So I mean, some of the stuff is kind of off the shelf, we pulled from the ecosystem, but some of these things are genuinely like new connectors or new orchestrators between the existing ecosystem and NXP's products. Let's give it a try here. Do you want to just, if it's really that bad?
Can we try again?
Sorry about that, everyone. Well, yeah.
Yeah.
Sorry about that. So, okay. So, I mean,
take off your headphone maybe, Hiram, and you just use your computer audio.
Nope. You hear or?
Yeah,
Oh,
you're
no,
still
pointless.
and I echo too every time you are.
Okay, all right. I'll make the executive decision to just continue. So, let's just look at this in terms of the frameworks and the tools. And so, on one hand, you have to have kind of runtime support. You need to be able to do the function calling. You need to be able to store things in memory that might be ephemeral, might need to be written by the LLM, for example. And at the same time, you have several emerging. I think people are probably familiar with things like MCP servers now from Anthropic, and what's kind of rapidly emerged to kind of power this stack. And it's kind of really the name of the game is marrying these two worlds, if you will. So being able to leverage the best of open source while still making it work with edge silicon, which is not how these things were designed initially. I see you're back. I'm hoping that you are echo free.
I'm not sure. Am I? Well, I mean,
sounded okay to me. Yeah, I mean, yeah, unless I see the comments blow up, that's just, you got this, man.
Okay. Then let me just give it a
Sorry,
second. Right. So basically what we're saying here, we have agentic works and tools to learn our tasks for autonomous operation. And basically we have right. So on the hand side, what you see here is an agentic framework. So that is basically the runtime support for executing task-driven workflows and leveraging modular tools and so on. And what we hear is that this orchestration is basically what enabling LLM to be able to execute on tools, right? So yeah.
I'm sorry to interrupt you, but we hear the echo. Maybe you could try to attach the headset and use the computer mic and just try.
Yeah, let me try 1 second.
Hiram, you're like me in that we both speak very quickly, so I think you don't give the audio enough time to get through. So maybe just a little bit slower, and hopefully the new microphone will work. I'm just what about now? Daniel? Yeah, just could you speak a bit louder? Yeah. Okay. Darn.
And what if you try to join by the phone? I know it's maybe it's not.
Yeah, I think I don't. I just had respect for the audience and also for the other viewers. I think maybe we'll go through the material. I don't want to get stuck here.
Okay.
So apologies. Yeah, thank you, Daniel, and really sorry everyone for the difficulty following. We'll just have to do another session sometime. But there's a couple of highlights here that I think we really want to make aware. So this is the flow. This is how we're making this autonomous operation possible. So what is enabled by this? I think that was really the takeaway that we wanted to have presented to the audience today. Is okay, we're more or less playing with the same rules. Physics don't change. The rules of the laws of the universe don't change from company to company, but definitely creative and opportunities can be different. So what is coming with agentic AI? Well, this is what you can conceive of as a kind of first stab at where we can make a difference in the world. So these kinds of things have happened, and unfortunately continue to happen, throughout, the beginning of manufacturing processes. But what's different now is the AI can supplement human response, human reasoning, one, without putting lives in the way, two, without kind of a loss of fidelity between calling the emergencies, calling the authorities. There's no panic, there's no fear, there's no emotions with an AI system. So the benefit of that is it can handle these high stress situations in real time, with good fault tolerance, because it's a deterministic system in some sense. And this is what this looks like, right? So, I mean, we talk about function calling, we talk about what can it do. Well, I think this is pretty practical. And so keep in mind, correct me, just shake your head if it's right. This is synthetic video. So no one was harmed in this process here. This is a AI. So before people think we're blowing up factories to train our systems. Now, this one I believe has audio. So I will stop talking and let it.
Let's showcase now the use case that we just described. We select the corresponding prompt from the drop-down menu and hit submit. And what we see here is that the agent is getting initialized, which means that the Quen model is getting loaded into the ADA2. Then this changes to processing, which means that the Quen model is now getting executed in the ADA2 for generating the code to solve the request. Now we see the code that is generated and the motor turns on. If we now switch to the WhatsApp view, then we can notice that the agent has sent the message attaching the image as requested. Note that we also report the agent duration and the TTFT and TPS for the Quen coder and the image query. So now let's try a simpler prompt. Let's just turn off the motor. And what we notice here is that the system goes immediately to processing because the agent has already been initialized. So now we see here the response and the motor turns off.
Okay, so I see that some of the audio is not understandable, but hopefully if you followed, what was happening on the screen, it would make sense, right? So essentially, like any kind of UI for generative stuff, you have your prompt input here. This is what's coming in here. You have an agent response, the image query, or sorry, the other way around. Sorry. So there's an image encoder, and then there's a response, and then there's the outputs here. I think you want to pay attention to these metrics down here, but all this stuff will be posted online, and hopefully it's a little more understandable there. It came through clear for me, so hopefully it was all right for others. But as the last, I think this is the last way to round out. This is our last slide here. Looking into safety and security for agentic AI. Well, we are, and I think that's by default, as I mentioned at the start. And here's a little sneak peek of what this looks like, because some people think, security with agentic AI is like guardrails. I actually think they're very distinct. One's about brand alignment, content alignment. Don't say bad words. Security is keeping people secure, and safety is keeping things people and things safe. So without going into too much detail here, I think this is, from what we've seen in the ecosystem, a pretty comprehensive and pretty innovative way of addressing problems that are emerging as we kind of build them here. I think one phrase is often we're building the plane while flying it. I think that that's somewhat true, but also, also not true in the sense that, we're working with systems and technologies and mathematics really that have been, proven for some time. So I'll let this, kind of marinate with the audience for a bit. Happy to discuss in more detail. And again, on behalf of Carol and myself, thank you everyone for being here. And we do apologize for the audio issues. But yeah, thank you for getting through this with us. And thank you, Daniel, and everyone for your time.
Thanks, Davis and Hiram. We ran into some problems of audio, but hopefully this can be managed in some way. What I suggest, Davis and Hiram, maybe is to, since the video demonstration that you shown were really amazing, but we had, at least me and maybe other people had audio issues. I don't know if you find a way to share these videos later on, or maybe when this recording will be available on YouTube, so that we can appreciate really, because you look very advanced on these things, and I think people can appreciate really the hard work behind your demonstration. So one quick question. You seems really advanced in terms of understanding about how much generative AI and agents are useful. So if you could summarize the real benefits from a user perspective, from an adopter perspective, with respect to the classic tiny machine learning. Being less technical and more user-oriented. How would you describe that as pros?
Yeah, it's a good question, and I'll say quickly, thank you for noticing that despite all the kerfuffles, we have I think good material here. So I appreciate that, Daniel. To your question, why this has been accelerated and prioritized, and folks like our CTO office and researchers are working on it, is because going back probably 12 months now, early reference designs and customer demos were really well received, and of course I think that's what prompted and really gave our leadership and ourselves the confidence. Your question is a good one and hinges on, I think, what the human benefit is of AI to humans. What I mean by that is I'll take a use case that is really clear in my mind of how it benefits humanity. It's no secret in North America, especially, that hospitals, nursing staff, doctors, wait times, it's a real problem. It's not a problem of time series machine learning models. It's a problem of people are not able to get the help, and the people that want to help them are too constrained in terms of time. That is a perfect application of agentic AI that without these kinds of LLMs, all the machine learning and all the GPUs in the world wouldn't be able to do the kinds of things that we're now able to do to augment hospital staff and to augment even medical workers themselves, not replace them. So I'm being clear that we're not working on a radiology machine that doesn't need a radiologist. What we're trying to do is introduce AI systems where bottlenecks exist at the industry level. So that's hopefully a not too long way of saying you're going to switch, but I think we're trying to focus on what are the bottlenecks independent of technology that exist in key markets: healthcare, automotive, industrial, of course, and appliances.
So essentially, in this domain, there are gaps that really need the technology solutions, which are essentially, if based with generative AI, these gaps can be fixed.
Precisely. Yeah. I'll take I'm in Canada, and Canada has a shortage of nursing staff like other countries. The solution to that is what? Hire more nurses? Well, you have to recruit, people have to want to do that, or you can introduce technologies that help support the gaps in the customer experience or the patient experience, right? So I think that's where we're trying to make AI useful.
Yeah. Can I maybe quickly synthesize that what we are looking at is essentially a new way, more empathic, more friendly, to establish conversations with agents, so that we pose questions or needs which maybe are a little bit imprecise. Normal people is not given to be engineers, so but still would like to be understood and support in their needs.
Yeah, I'll borrow something I saw from NVIDIA at the PyTorch conference, where they have what's called a physical Turing test. And so they're using synthetic video to help support physical systems to pass what they call the physical Turing test. And of course, that's a classic test of intelligence or consciousness. But I think you kind of capture that essence in the nuance and the variability that agentic systems capture, like humans, right? We all have uniqueness that has to be accounted for.
Yeah. Another question in one of your slides, I saw, for example, ARA processors were capable of, if I noticed it well, 40 tops, and then to achieve more, essentially there was a symbol like repetition of these blocks. Do you see this as the only direction to go to scale up performances, or do you see also other directions, for example, in memory computing, or I don't know, maybe other directions that are worth to consider, even from a research point of view?
Yeah. So I'll give. Hopefully you can, but I'll give a quick answer. No, it's not the only way. So you did catch that correctly. 40 tops is the sticker tops. They have their own memory, but they need a host, right? So the idea is you can combine multiple RA2s with a single host. But there are other ways that you can, elevate the compute performance. Some things are not as, researchy or clever as like in-memory compute or advanced stuff like you're saying. I've also seen some solutions proposed, like run it on a mobile app or call a central, like if you need more larger LM and the NPU serve as like a front end for multimodality or vision encoders or something. We have seen companies in automotive and other places say, well, maybe let's leverage other compute for that kind of stuff. But I don't want that to take away from the fact that, analog and more advanced semiconductor design is definitely going to have a place there.
Very good. And if you allow me another point, Davis, I remember we discussed during the US Edge AI forum how important was differentiation in TinyML about hardware solution. Do you think this is even more true with generative and agentic AI, or are we going to see a kind of standardization de facto or not de facto about these hardware for that for generative and agentic? What's your
there was a big echo there. I hope that wasn't me. I think as much as things start to feel like they're coming together, we're still in very uncharted waters in a sense. And so I don't want to hamper what could be by trying to focus on standardizations or common places. We have people like Yann LeCun at Meta saying LLMs are a dead end. I want to go explore something else. So, while we're kind of all focusing here, maybe other people need to go there to find something new. But there definitely is a lot of power in having, as we've seen with, camera interfaces and mobile industry and others, where standardization does help everyone elevate, but it's hard to know when that's happening when you're in it, is my 2 cents.
Fantastic. And I'm sorry, Iram, you cannot comment. I would really love to hear from you. And maybe another question, maybe if you speak slowly, who knows, maybe the echo will be less.
Is the echo still present on your side?
No, not at this time. Not at this time.
Oh, wow. It's a timely thing. Okay.
No, but really, I would like to hear from you. Any comments on the things presented, or just the question I posed? I would like to hear from you, certainly.
Yeah, of course. I mean, I think you were making a very interesting question, especially with regards to thinking about how do we create these solutions that are no longer just about running the mobile, right? Because of course we need excellent hardware, and I think we have there's a capability to do that, right? But especially when we start going towards the space of agentic AI in particular, it's no longer about just running the mobile at a very fast speed, right? We now need to start thinking about more like system level solutions, where in particular in that space, I think we suddenly put ourselves in the position of thinking, hey, how do I also make this general framework for creating this scale? How do I make the solution also safe? How do I make sure that nobody actually, that actually people can keep this up and continue developing from here onwards, right? So I think it's this a bit of a paradigm shift in that regard, and of course, and again, thinking about the efficiency aspect, well, the mobile running fast is a part of it, but now we're talking about a complete system solution, right? So we need to think about more like system architects in terms of how can we best analyze compute bottlenecks all throughout the execution chain, not just the mobile, maybe now the tools as well, and how can we make this as efficiently as possible. I think that's it's a very interesting thing and a very, very interesting field to be at the moment.
Maybe Iram, another point I would like to briefly discuss with you. At the beginning we had the it's trivial to say the cloud and the tiny devices, and then we started the generative at the edge topic last year with Davis, and then I quickly realized that the industry was moving really fast, and then on-premises solution started to appear, and then I was a bit surprised because in so short amount of time, near user computer or near consumer computing, depend on how it is called, products appear. So we had 2 and now we have 4. And I wonder, what's your opinion on that? Are we at the end, in the sense this will stabilize, or there will be even more segments in between? What's your opinion on that?
Yeah, it's a it's a very interesting question, and at the same time very challenging, right? Because I think typically what we try to think for ourselves is how, like, to what extent can we predict what will happen, especially in the space of AI, right? Like no one could have maybe predicted the moment where ChatGPT happened, or what will happen in 2 years from now, right? But I think what we do see now is that things are really going, for example, in directions which perhaps, especially in the edge, we wouldn't have foreseen before, like thinking about this generative models now driving robotics kind of applications. So I think rather than stabilizing, I think it's reaching to a point where we are identifying how can we actually power day-to-day use cases with the technology that this large language models and so on are enabling. Where does it go from here? I think that's a great question. I don't think I have a concrete answer, but this is actually what the main reason why we are here, right? To share ideas and to actually together kind of understand how things move forward.
And I really apologize, but there is
no worries at all.
a unique opportunity, and also I didn't hear from you during the presentation for the audio problem. So Iram, and maybe Davis, it's up to you to comment. I'm happy if you comment both. But you know, in TinyML we had these frameworks based on TensorFlow Lite, ONX. You know, these at the end, these were the representation, the most popular representation around which the community consolidated. And now we see Llama CDP. There is ONX GenAI runtime popping up. Do you think we really are experiencing a departure from the framework we saw in TinyML?
Yeah, I'm still. I mean, I've noticed this too. So I mean, it's you kind of carried the thought out to where it go next. I think a part of it's not just random. Like part of it's due to factors that aren't maybe deliberate. Like there are people that drive these things, and people work at these companies like Google with TensorFlow and PyTorch with Meta. So sometimes they kind of unfold in ways that are very hard to predict, because there's just behaviors and patterns that don't even know about until it kind of starts to emerge. But it does seem that there is like a branch shift, or like a fork in the road between the the legacy, sometimes they call them legacy frameworks, even though people still use them. Tiano was one framework that maybe people don't know about it now, but it came and went. And so I think it's a natural evolution, but I think even GGUF is a new one you mentioned as well. ONXRT is there. We have to wait and see. I think it's I would welcome it, but it becomes a bit of a nightmare to manage all these tools and frameworks. So probably everyone knows that. Yeah, I don't know, Hiram. What do you think?
No, I mean, I fully agree. I think in a way you can kind of look at it as going up in the stack, right? Like the mobile specific things seems to have leaned towards storage, and at least like generally speaking, CNN space perhaps. When you start thinking about deployment of large language models, then of course, you start seeing Olama as a serving framework, but perhaps the most popular de facto format right now is GGUF. But then you start seeing that same trend happening even above that layer, right? So of course you have the server framework that needs to be there, but now, for instance, again talking about agentic AI, now you have the agentic AI frameworks, right? Which simply because they are like in the upper layers of the stack, there's like a vast amount of frameworks out there, just literally coming out by the day. Probably even more so than deep learning training frameworks back in the day, right? So it's getting very complex, right? Some of them are perhaps more focused for edge kind of use cases. Some other are more cloud oriented. But how do you then bring this to the edge, generally speaking, and how they are like interoperable across these? It's a big challenge. So I think we're starting to see that pattern emerge again and again. How will it stabilize? I think that's a good question.
I hope people are still listening. I feel like the three of us could just talk all day. So.
Yeah. Maybe Peter will forgive me because it became a fire chat.
Yes.
Yeah.
Oh, very welcome.
Okay, so let's stop here. Thanks so much, Davis and Hiram, for your outstanding availability. Really, it was also an opportunity for me to discuss a few things with you. And also, I think these are of benefits for the community here and the people that will see these records later on. I think it's useful.
Agreed.
Topics important because we are in front of a huge transition. And maybe we are uncertain about where we are going, but definitely it's a direction to where to go. So thanks so much, really thanks. And let me switch to the next speaker. Hi, Enrique. First of all, apologize to let you wait. And
no worries.
I took so much time in the speech before. Eric Flodel, Alif Semiconductor, Genaya the Edge for Endpoints, and I'm happy to leave you the floor. Thanks.
All right. Thank you so much, Danilo. I'll see if I can get my presentation underway here. Let's see. There we go. I think you should be able to see this now, right?
Yes, correct. Yeah.
All right. So I'm going to talk a little bit about generative AI at the edge for endpoint specifically. And the context, of course, of my talk is mostly around Alif Semiconductor and the products that we bring to market that enable this kind of technology to run locally on small battery-powered devices. I just want to start very quickly with an overview of Alif Semiconductor as a company, because I realized that maybe not everybody who is watching this talk is familiar with us. We're a young company. We haven't been around quite as long as some of my esteemed friends that also participate in this event. In fact, we were founded back in 2019. And since then, we've gone through a couple of product launches. We had our first devices from our Ensemble series of microcontrollers and fusion processors come out of our fab in 2021, and since then we've been shipping those to customers. These were actually, as far as I understand it, and from kind of memory all the way back from when we designed this back in 2019, some of the very first general purpose microcontrollers with integrated NPU units able to run trained deep neural networks next to an MCU core in a SoC MCU type solution. We spent a couple of years after launching the first Ensemble devices building out our ecosystem of software and support. And then in 2024, we introduced a family of wireless devices focusing mainly around BLE wireless connectivity and also 15.4 type connectivity that also include the same type of AI acceleration unit. So essentially, the industry's first BLE device with an actual on-chip NPU for running your AI. But what I'm going to talk about here is what we announced at the beginning of this, that we now started shipping in mass production quantities to customers. It's the first microcontrollers that features NPUs able to fully accelerate transformer-based networks. So essentially enabling very efficient execution of neural networks that contain generative AI properties on device. So high level, I like to kind of introduce the company by using this slide and some of the things that sets us apart from other microcontroller suppliers. I'm not going to go into details on the scalability, but I wanted to put this slide in here to just kind of talk about why we have chosen to add this acceleration of AI into our microcontroller devices. There's a lot of systems out there that essentially converts the models that they've trained to C code and just run them on the CPU core instead. What Aleph essentially does is we develop ultra low power microcontroller solutions. And for us to be able to hit those low power levels, we really have to kind of focus on two separate things. We have to focus on being able to run the firmware part of the application very power efficiently, both in terms of being in a low power state when the application is sleeping, but also once we're actually doing work, when there are things, data for your application to process, we want to be able to do that data processing as quickly as possible, even though momentarily it might use a little bit more power to finish doing all the processing, because once we're done crunching the numbers, we can usually go back to sleep, and that's what's going to save you battery over time. So essentially, the Aleph devices, while very capable when it comes to running AI machine learning locally, we do that simply to make it possible for people to design systems that can be battery powered and very, very, very small. Some of the modern wearables in the consumer space, like AR glasses, smart rings, smart pendants, etc., have some extreme constraints on the system in terms of physical size. And the only way that we can enable them to, apply the type of design that they need to the end products is by making sure that this last bullet here, the Edge AI, is able to be handled very, very efficiently when the right amount of data have been collected, when a trigger has been identified in the incoming data stream, so that we can process that and make it possible for the result to be presented while not using the CPU core for an extended period of time to figure that out. So at this point in time, we have we actually have 9 families of our devices in the market, and they all feature some level of integrated NPU capabilities. The first generation devices that we launched, the E1, the E3, the E5, and the E7 series of our Ensemble family, they were using ARM's Ethos U55 NPUs across the board. But in the most recent series of devices that we've introduced, the E4, the E6, and the E8, which is what I will be talking about going forward in this slide deck, we've also included ARM's Ethos U85 neural processing unit. And it's this U85 that adds the capability to hardware accelerate the transformer operators that essentially brings the generative component to generative AI workloads. So CNN networks, RNN networks, and now transformer-based networks, fully hardware accelerated in the Ensemble family. So why would anybody really focus so much on wanting to run these type of networks directly on a small wearable device? Is there really anything wrong with kind of the paradigm that existed before, where the embedded device was essentially recording data and transmitting that data to either a cloud or something like a mobile phone in order to perform the AI inference operations there, where less constraints exist. Well, there is actually quite a few reasons for wanting to deal with the AI part of the workloads directly on the device. For instance, if you're working with any kind of health metrics, there are usually laws in place about how you as a device manufacturer need to protect user identifiable data of that nature. And having the data located on the device and having it not leave the device, having all the processing done on the device really helps with preserving that privacy. A case can also be made for any type of AI that deals with analyzing something like, legal documents. We've seen a lot of use cases for building up smart systems, smart GPTs that focus on trying to figure out the ins and outs of those type of that type of information. And in those cases, it might also be extremely important to just protect the integrity of the material, not have that be possible to be accessed by somebody else. Also features like transcribing conversations that happen in business meetings. I'm sure that you've all joined calls like this, where a number of AI agents joins the calls in order to be able to transcribe what was said and to forward that to the attendees. That's a feature that you may want to limit exactly how the content of the meeting gets shared among the participants for privacy reasons, and also for some very compelling business reasons in some case. Some of the other use case or reasons for wanting to perform the AI workloads on the device have to do with essentially latency. If you are creating a wearable that is supposed to be detecting things that happens to the person that is wearing it, having that detection not deal with the round trip all the way up to the cloud and back again just gives you more time to react to the situation as it occurs. The example on this slide is, for instance, for a fall detector for the elderly. You'll be able to respond faster if that does not have to be transmitted out for the fall to be detected. And then there's other use cases that fully depend on the latency being essentially non-existent, like, for instance, noise canceling headphones. You want to be able to still have essentially the sound arrive in real time, which makes it very impractical to try to do that type of task off device. To be able to have a device work in a remote area where there might not be connectivity to send the data out, for instance, if this is a wildlife camera that is deployed somewhere where there is no cellular coverage, for instance, or if it's something that an emergency response team needs to carry with them when they go out to deal with a situation that is just occurring. On-device AI is very, very important for these type of systems in order for them to be able to function across all the places where they might be deployed. And then also, and very important these days, to just reduce deployment cost of the system. If you have to send all the data that you record up to the cloud all the time, you incur a significant kind of debt when it comes to all the data that you're now storing server side to try to figure out exactly where the interesting pieces of data amongst all of this that I'm recording. And to also be able to better take advantage of all of these nodes that sit on the edge and do the recording, and just have them participate a little bit in trying to make sense of the data that they're continuously recording. So we've seen quite an evolution when it comes to how AI is being deployed into edge-based systems. And I have some examples of that on this slide here. The thing that I really wanted to focus on is the example in the gray box here. AR glasses is becoming a very popular piece of technology that is being developed by a lot of companies in parallel. I'm sure that over the next couple of years, quite a few versions of this particular use case will hit the market. But it's a good use case to kind of point to highlight some of the actual constraints that exists when it comes to how you deploy technology in the form factor. A pair of glasses that weighs more than about 40 grams becomes uncomfortable over time for the wearer. So it's really important to try to keep the weight of the system down. That includes the battery, that includes all the electronics, and that of course includes, lenses and the plastic assembly, the frames and all of those things. This is a hard requirement for the electronic manufacturers to work with, because they're used to being able to take up some space, and some of the NPU solutions out there have some terminals that you have to kind of deal with in order to be able to dissipate heat properly, which is a difficult kind of physical it's just real life physics that you have to try to pair up with the form factor in general. They also have to support cameras for collecting data, audio interfaces, microphones, those type of things, and also enough memory resources inside the system to be able to realize the use case. There's a lot of constraints that exist in these kind of platforms that becomes very difficult for designers to work around if they don't choose technology that is very good at doing all of these all of the math that is required for this locally. There is a lot of challenges on folks like us that design the SoCs for these type of use cases as well. Of course, performance is something that everybody needs right now for the ultra low power type devices that deal with Edge AI. The performance does not go up to the double-digit tops that people are looking to use in future iterations of these kind of products. There's also some traditional bottlenecks in terms of microcontroller type solutions when it comes to just data movement through the devices. Are there grounds that can be broken here by companies that are providing this type of technology to overcome some of these bottlenecks? And how will we guide people that try to find the right technology for their applications that enable the battery life to be up there in the weeks or multiple weeks worth of battery life without having to recharge the system constantly to make it awkward to use, simply because of those types of limitations. So there are a lot of real constraints when it comes to trying to deploy these type of workloads on the device directly, rather than relying on the unconstrained cloud side. The other thing that we at Aleph Semiconductor, and I'm sure that a lot of you that are listening to this as well have started to note, is that the software ecosystem around deploying AI solutions is evolving very, very fast. Traditionally, when it comes to the type of frameworks that model development has happened in, that have then gone on to be deployed at the edge, I think there has been essentially TensorFlow has been the go-to framework of choice for these type of deployments. We're seeing, in terms of established deployed hardware solution, we still see an edge of TensorFlow deployment versus deployment from other AI frameworks. But that's definitely something that we see a shift in when it comes to customer interest or user interest. I put some statistics on this slide, just comparing, for instance, from Google Trends, the interest in PyTorch-based models versus TensorFlow-based models over time. And as you can see, this blue line here that essentially indicates the number of times people try to find PyTorch models that can perform, certain functions, be they image classification things or, whatever it might be, that is now eclipsed the number of searches for similar types of models developed using the TensorFlow framework. And on the research side, this is data from a paper that was presented some time ago by a couple of researchers that were essentially looking into adoption in industry versus, interesting research for various AI frameworks. You can see that there is a considerable uptick in interest for models that were developed using the PyTorch framework over TensorFlow, simply because, a lot of people prefer PyTorch as a method for working and developing this technology. And for Edge AI developers, having access to a rich set of models that can be trained rather than designed from scratch is very attractive. So this is another thing where we kind of, looked at how do we enable people to then work with models coming from this particular framework over the TensorFlow framework, since that seems to be where a lot of the generative technology is landing at the moment. So we have in our lineup of products now introduced this Ethos U85 NPU in 3 series of our devices. So they fully enable hardware acceleration for generative AI workloads by supporting transformer operators at a very low level. And we've also enabled the executor runtime for these devices so that a model developed in PyTorch to leverage transformers, be that a language model or something that deals with vision-based data or audio-based data, can be fully accelerated on the device. It gives us about 58% faster inference rates compared to running the same model with transformer operators executed on the CPU core from our Ethos U55 based parts. And we've also made some significant updates to just the memory subsystem in these devices in general to even faster be able to output tokens, especially for language models like you see on the video that is played here. So this is a demo of a AI, or actually of a Llama 2 model that we trained on the Tiny Stories data set. We take a picture, we use the object in that picture to construct a prompt for the small language model, and then we call that multiple times to generate a story about the subject in front of the camera. So it's a cheesy little demo, kind of geared towards, you know, making intelligent toys that children can interact with. But it just shows that the capabilities of doing LLM type text generation on an embedded device is indeed possible. And I also want to show you a different type of demonstration of this that we showcased at the PyTorch conference recently. So I hope that this is going to work, because LinkedIn won't allow me to download this video. But essentially, this is speech to text, and this was demonstrated in ARM's booth at this conference. We have ported the conformer demo to one of our boards. And if you could hear what George was saying there, he essentially introduced himself, said that his name was George, and asked how the model is, and it was immediately able to translate that, or to transcribe that, what he said, into text and output that to the screen. So this is something that we're now starting to see people pick up on and use in actual applications. So that's essentially what I wanted to go over here. I wanted to leave some time also for Q&A at the end of this, but I wanted to end on this slide here. You can, of course, visit our website for more information about the product family. But more importantly, do pay a visit to our GitHub, github.com/alexsemi, to grab the port that we made of the executor framework, and also some of the examples that we've already brought up to that, to start working with generative AI in your microcontroller-based project, and to bring these up into more embedded, truly embedded edge-type devices. So thank you so much. That was what I wanted to go through in this session.
Really grateful, Henrik, because it was an outstanding presentation. First of all, I was really touched by the initial, one of the initial statements in one slide, that on 2025, Aleph Semiconductor was putting in the market a microcontroller capable of generative AI. And I was a bit surprised, you know, because there is a paper from Vijay Janapareddy, professor at Harvard, where essentially in a taxonomy published on this paper, GenAI on microcontroller was a yellow card that was challenging, but it was not, I mean, at the point that you put on the market. So maybe, I don't know, at the level you could, can you comment a bit, what does it take, I mean, to put a GenAI microcontroller on the market? What type of intuition did you I mean, did you have to come out with such a development?
I think the way to think about this, right, is you have to kind of decouple the thinking when it comes to generative AI at an endpoint versus how people are kind of imagining LLM solutions that run cloud side today. Because these large language models that we interact with online are essentially being trained on all manners of data sets simultaneously, so that you can essentially ask them any question and get the right type of answer. You don't necessarily need to be that generic always in an embedded system. There is usually certain, topics, verticals, however you want to try to kind of draw bounds around that the device needs to concern itself with at any given point. There might be situations where, the context of the wearer of, a device, for instance, only need to use it to translate from, one specific foreign language, translate text from one foreign language to another, for instance. It doesn't need to know all of the languages that are out there at the same time. So there are ways that you can kind of structure your model to be able to perform tasks leveraging generative AI properties while not necessarily needing to have all the knowledge concentrated into one model. We see a lot of use cases where essentially data is being collected and they're processed using transformer-based networks at different, let's say, distances from the data collection source. So on the device, you might be looking for certain properties in the data that you're collecting, and you want to be able to, handle them very quickly with extreme low latency because they are the most important. If you don't find any of that type of data, then the data that you collected can be moved on to something like a phone or a cloud-based model where a more deep analysis can be performed, where the latency is not top priority for the round trip of the answer anymore. So I hope that made sense, but that's at least the way that we are thinking about it. We strongly believe that these type of solutions will be essentially parsed out into different tiers, and they will need to be processed in different ways.
Thank you. And in one of the demonstrations that you shared in your presentation, there was the clear example of how detecting a person, maybe with traditional machine learning, not generative, then was synergically working with a small language model, tiny story, okay, trained on purpose. But really, he showed the synergy between these two paradigms, and which are different, obviously, and making them to coexist. Do you think this is something, if I understood correctly, so if I'm wrong, please say so. But do you think this is something that can really be transferred to the developers, which are maybe more familiar with tiny machine learning and less, not yet, maybe with generative AI?
We really do believe that this is going to be a faster way forward, especially when it comes to dealing with image-based data. There are a lot of, and it feels a little bit strange because this is really a field that have moved very quickly. It feels strange to talk about something like processing imagery with AI models at the edge as established and stable technology. But on some level, it kind of is. This is something that people have now been doing for a number of years very successfully, and they've been able to develop robust systems to be able to analyze incoming image data and make, on-device decisions about what is contained in the image, what is going on, what is the person's sentiment, et cetera, et cetera. So to kind of extend those capabilities with additional functions from a generative AI model, trained to provide insights based on what happened in front of the camera sensor, it becomes the next natural step for a microcontroller-based system, because that is the next level of integration in order to add additional capability to make the system as such capable of agency without being connected to the cloud at all times.
Very good. And if I may, another question. I was really polarized on frameworks so far in my experimentations with frameworks such as Olama, Llama CPP. But by the way, Olama exploit Llama CPP and mostly. Then I saw the rise of ONX GenAI, but you essentially centered in the demonstration that you shown the point around executorch.
Yeah.
Maybe could you summarize why you and what are the prongs that makes you more comfortable in this direction than these other that anyhow are on the table?
So I can't necessarily speak to like which framework is naturally to be preferred over some other framework, because kind of as I mentioned, this technology is developing, or the software side of this technology, I should say, is developing extremely rapidly. So it's more about trying to essentially support the frameworks where more R&D type initiatives are occurring, right? So when we started out, we don't develop our own proprietary MPU cores. We license our MPU technology from ARM. One of the reasons for that is specifically because of this fast-moving software environment. We believe that licensable technology makes the software ecosystem gravitate towards it because there will be a broader user base for them. And the initial enablement around our MPUs was constructed very much around TensorFlow as a framework. And frameworks like ONNX at the time, before ONNX RT, you had conversion options to take your ONNX model, turn that into something TensorFlow based, and then the tooling that makes it deployable on the MPU could, pick everything up from there. But we did have a gap in that tooling specifically for PyTorch, and there is a lot of development of generative AI models, or models using generative AI properties, I should say, on the PyTorch side, that people certainly have a big interest in experimenting with. And we wanted to figure out how can we make it possible for them to do that without losing a lot of model accuracy through multiple conversion steps to go from a Python-based source into something then converted to TensorFlow that can be deployed on the MPU. So we see Meta's effort in creating Executorch as a great way to essentially enable this for the edge devices. And we wanted to very early on be able to bring that up and provide it to users so that they can experiment with these type of models without that loss of accuracy that kind of impairs the ability to move from what they have imagined that they will be able to do to actually realizing that in real products.
Thanks so much, Enrique, for all these comments. If you permit me, just one last question. Clearly, for all of us in the industry, business is business and the customers are the priority. But on the other side, I feel that the community, that the machine learning community that we serve need more and more knowledge sharing in terms of generative AI at the edge. So what are your thoughts on educational program to ease that and to meet that need, if any?
Yeah, no, I'm a very strong believer that, essentially just because of how this technology matures and percolates into educational environments, the next generation of computer scientists, if we can talk about them as computer scientists and not data scientists specifically, for them leveraging this technology will be a lot more common, right? It's something that they will have done all the way from, when they started learning how to put applications together by using AI tools to help them, perform that part of the development process, but then also to rely on this type of technology to provide certain aspects of their solutions to a much higher degree than a traditional embedded developer that might not ever have considered running a neural network inside their solution. And if I can call it hesitation that usually comes with adding an unknown quantity like that into an established development flow. So this is something that I think over time is going to normalize for a lot of developers, and we will see a significant uptick in just the adoption of this type of technology from scratch into embedded designs in the years to come.
With that final comment, Enrique, first of all, it was a pleasure to meet you and to hear from you. Thanks for your time. Thanks for the availability to speak to the community. It was a great talk, and also to have addressed a few questions. Thanks for your time again.
Thank you.
And time to switch to the last speaker, Roberto Morabito from Eurecom. Before I leave you to speak, Roberto, I would like to remember that Roberto is an active, a very important person, active person in the Edge AI, in the Generative Edge AI working group, and he continues to contribute in a remarkable way. So, first of all, thanks, Roberto, for that. I think it's really appreciate your proactivity. And today I thought to invite Roberto because he will share with us, an helicopter view about all the contributions that we heard in the previous forum. Single contribution are very important, and we need to interact with the speakers. You clearly saw my extended time with Enrique and with Davis and Iram. Really, it's important to focus on the single contribution, as well as is important to have an overall view of all the contribution. And I think Roberto is really instrumental in supporting all of us to get this understanding. Correct, Roberto?
Thanks. Yeah. Thanks a lot, Danilo. Thank you so much for the kind words and the introduction. Yeah, so I can perhaps start sharing
please. The floor is yours.
Yeah, thanks a lot. And can you see the slides?
Yes.
All right. Okay. Then, yeah, so basically, as Danilo was mentioning, the purpose of this talk is not really to go deep from the technical point of view, but it's more like a reflection, and that's why I think it could also be a nice opportunity for bringing some insights before concluding these 2 intense days where we had a lot of interesting stuff ranging from a wide different topics. And what I wanted to do with this presentation was mostly trying to understand how the generative Edge AI has been evolving since the first forum, which was done in March 2024. And before getting to that, just as also Danilo was mentioning, these different forums have been organized by the working group, Generative Edge AI working group, in the context of the Edge AI Foundation. And I highly recommend everyone to have a look at the working group mission and all the different, basically the charter of the group. You will find a lot of interesting information, and also what's the purpose, the main purpose, although might seem pretty clear based on the different activities that we've been running in the last year, a bit more than a year. And I wanted to highlight specifically the mission statement that it's included in this white paper, let's say, or charter of the group. And especially I wanted to highlight this aspect of trying to merge different worlds, academia, industry, individuals, with a purpose for kind of boost this collaboration around these emerging topic of generative edge AI. And I think, and the purpose also of this talk is to try to some extent to prove that we are actually doing this. And I'll try to go through what we have seen throughout the different forums. But before that, just some additional context on where we are standing today. We have seen similar slides in these last couple of days, but just quickly to remark that, of course, one big impact that somehow is bringing to the and boosting the feasibility of generative edge AI has been given by the incredible amount of releases of small language models as open source. You can see in the graph, the top graph, that especially in the last year, in 2024, this is not really updated for 2025. There has been a massive release of open source small language model. And this has, of course, has had a lot of implication respect the entire ecosystem of generative edge AI and its evolution. And this is also reflected from the research point of view. You can find here some data on the research papers that kind of had this small language models tag in their title. This is pretty much growing exponentially. 2025, we still have a couple of months for updated, but you can see the trend. It's quite clear already from let's say from R&D point of view where we are heading. And also this was another figure that plot that was shown yesterday about the trend that we have been observing and has been booming. This is like a Google search index term. We can notice how in the second half of the 2025, the interest towards small language model has been increasing dramatically. And yesterday was nicely pointed out that this came in correspondence of the release of this nice paper from NVIDIA researcher that clearly identify small language model as the key enabler of agentic AI at the edge. But that's not the only thing happening in the period. There have been a lot of also contribution from the industry, from many big players that somehow start to releasing very smart model, for example, including the reasoning capabilities, but also the tool chains and different software tools that to some extent start to simplifying more and more the use of generative edge AI and also hardware. We have seen now the last presentation, which was also focusing quite a lot on that. So it's really the ecosystem is growing from multiple dimension and again from R&D perspective, which I think it's very nice. What I was also curious to see, and this was somehow very interesting to me, is that I wanted to compare the growth of the edge AI, also how people start to get interested on edge AI, if there was somehow some relation respect the small language model. And this was quite interesting. I wasn't really expecting this. To observe that there is a kind of overlap, almost one-to-one, I would say, between the small language model interest towards small language models and edge AI. I think the interpretation respect this kind of trend can be diverse, definitely. In my opinion, what we can say is that the edge AI discussions as clearly accelerated when the SLM capability did. But also I would like to perhaps highlight the fact that the technological enabler that we have with the smaller language model has also brought people to look back at the important contribution that edge AI from R&D point of view has been bringing the last few years. Edge AI is not anything new. I mean, it has been around already since many years, and I think what is important to remark is that many of the concepts and intuition that researchers have had when bringing to life Edge AI can be reapplied, of course, fine-tuned when thinking about the development of agentic AI for the edge, a small language model, and so on and so forth. So I think this was quite interesting insight that I wanted to highlight. But now, getting back to perhaps the core of the presentation, and I really wanted to go through the different insights and seeing especially how the things have been evolving in just 16 months, essentially 18 months. The first forum was done in March 2024, and when still the Edge AI Foundation wasn't Edge AI Foundation, still a TinyML Foundation. Also, the second forum in October 2024 was under the TinyML Foundation umbrella. Actually, if I remember correctly, the announcement of the Edge AI Foundation came a day after the second forum, or a couple of days after. And then in the last forums in 2025, the two forums that we have had in May, and this one currently ongoing and soon wrapping up, started yesterday. And I was looking at the different contributions, how things have been evolving, and I was very impressed and interested to see how the kind of exponential curve that we have seen for the research paper can actually also be observing the quality of the contribution that different practitioners are bringing to the whole picture. Just to give you some additional insight, I've been trying to identify some sort of waves of evolution. I'm getting to that very shortly. But before this, I wanted to highlight that across the 4 forums, we have been hosting 48 organizations presenting some contribution. We have had universities, semiconductor leaders, startup, major tech companies, a research lab, even non-governmental organization. And this clearly showed the cross-disciplinary nature of the generative Edge AI and the high, also the wide set of topics to some extent also that these different organizations can also bring. These are somehow reflected in the different technology domains. And in this 48 organization, we can of course, I've been just looking at how many belong to academia. I think there is like a nice distribution. Also, I do see, I've seen recently, we were also exchanging some email with Danilo during the past week, that there are, for example, more and more these kind of challenges organized by NGOs where these NGOs are trying to invite people to reflect how generative AI can be used also for solving important issue in the globe. So I think there will be also, when it comes in the coming months and years, an increasing balance, and with all these different actors involved more and more. And I think this was very nice. It kind of shows the scale of how the evolution is happening at the moment. And the other, here it comes, the 5 waves of evolution that I wanted to highlight. And it's pretty clear looking at what we have had in the forums since the first forum, is that we started, kind of down to earth, in the sense that the main discussion during the first forum was essentially trying to answer to the question, can we really run small language models at the edge? It was more matter of discussing the feasibility of this. And nowadays, what we have seen today, what we have seen yesterday, we talk about the multimodal models, agentic and distributed agentic Edge AI. So the world has completely changed in just 18 months, and I think this is very impressive. I'll try to quickly go through these different ways for comparing what we have had then and what we are having we are ready now. And the first wave, just to give you some insight here, during the first forum, in the first two forums, we were talking about, running LLM on a Raspberry Pi, optimizing single LLM inference on a specific CPU. Now the conversation has shifted not from answering the question, can we run model, but we are talking about a full generative AI stack, tool chain, pipeline, distributed agent framework, accelerating the LLM inference at the edge. So it's not just a feasibility question, but the optimization. So things are evolving, have been evolving quite nicely. When it comes to the other aspect that I wanted to highlight here, this concerned the fact that we have been initially looking and focusing mostly on sort of on-device execution, tiny optimization. But now what we have seen during this last couple of days, we talk about distributed agentic AI at the edge, end-to-end edge Gen AI. So the complexity and evolution is very remarkable, and I think this is very nice. And again, let's not forget that this kind of evolution, it doesn't just come from the industry, but there are many actors, as we have seen in a few slides before. Then, very importantly, in my opinion, is that initially the kind of matching respect to the use cases was a little bit weaker respect to what we have now. But for example, what we have heard today is also a strong focus on trying to understand to what extent we can use agentic edge AI in different contexts, from the automotive, healthcare, to wearables, industrial. So this is an important shift, and this also will connect to some data that I will show you a little bit later in the talk, and respect some work that we have been also doing within the working group. And also initially there was a lot of it was mostly about feasibility, right? And the use cases were mostly targeting the LLM execution, chatbot or textual output that we can get from this model. But nowadays, the multimodality is a fact. We have, we have listened about and gesture modeling, artificial sensor in the context of e-health, real-time audio denoising, visual language models. So also the multimodality, along with the reasoning, I would like to add, it's something that is already happening. It's not something that we are just envisioning for the future, or something that will come next. And I'm talking about multimodality at the edge, not something that we can expect happening at the cloud only. And talking about vision, a year and a half ago, there was a lot of course, discussion, the big vision, what are also the problem and the feasibility problem for edge AI, and the kind of the intersection with foundation models and small and large language model. But today we are talking about tool chain and software architectures that can essentially represent the backbone of this complex ecosystem. Of course, there are still a lot of things and issues that need to be solved. Also, we just heard in the last presentation that it's not everything perfectly working. There are still a lot of optimization. If I think about for example, something I'm also personally working on about the quality of the answer we can get from the small language models, the level of automation, full automation that we envision in the future. We are still far, which is good to some extent also from a research point of view, because it means that we have the possibility to still address many of the pitfalls. So these are the 5 waves that I've been observing when looking at the different 4 forums. So again, it's just 1 year and a half, but as you can see, the evolution has been quite remarkable. And when it comes to the vision also and the insight from industries, in the context of the working group, we have been in detail look at and describe what has been happening during the first 2 forums. We described together with the vision and the mission of the working group. We have described this in this white paper that it's freely available online. Perhaps we will do something similar, including the contributions and the insight that we can derive from the 2025 forums. But what you will also find in this white paper is the results of a survey that we have been running some time ago. Perhaps it's soon time to look at it, given the drastic change that we have been observing in this such a short time. A survey that was run among the AGI Foundation partners about the vision and what we would have expected at the time with respect to the generative Edge AI way. And I would like to quickly go through these results. The first thing was we were asking about the market reachability time frame, and I think you can see that already. This was like the survey was done early this year, so you can see already that there is a quite clear clarity on the fact and belief on the fact that the reality of generative Edge AI is something that it's already happening or soon coming. You can see that 2026 and 2025 basically take the biggest portion, 70% of these. We are not talking about feasibility anymore, but we are talking about market reachability. So it's something different, something a little bit more evolved. So this is extremely important to keep in mind. And again, these insights are coming from people in the industry. So we should definitely keep in mind these. At the same time, we were asking what were perhaps the main barriers at that stage, of course, that were somehow limiting the adoption of a generative Edge AI or the development of the ecosystem around this area. And here, what I would like to highlight is that it looks like it's not really something that can we connect to engineering or research aspect of this, but it looks like more the readiness of the industry to adopt generative Edge AI and bring it to production and in the market. Of course, we should always consider that this evolution has been extremely fast. It's very hard to cope. Me as a researcher, it's very hard to cope with tons of paper popping up every day about this area, not only large language model, but even nowadays generative Edge AI. So I guess in a structured organization like companies and industry, this can be even trickier, especially if we're talking about products and market. When it comes to use cases, here we had a pretty balanced insight. There was a big portion that was taken by the small language model. I think that's still the case. Of course, within the small language models, we can have a bunch of different sub cases, but also I would like perhaps focus also on the other use cases that the community thought deserve specific attention. And also here, what you can say clearly see. What we can say and clearly see is that multimodality is the answer, because we have the visual Q&A, speech to text, image generation. So I think that the multimodality aspect is very well reflected here, and I expect that in the future we will there will be more and more investment and work from R&D point of view in this respect. The other two questions were relating mostly on the impact. On the left-hand side, we can see that we have a pretty much fair balance between what are kind of the solution that are likely to emerge within a certain time frame. I mean, it wasn't specified like within the year, but in the future, respect the generative Edge AI and hardware and chips and application are taking basically 60% of this portion. But again, it's quite balanced. I think that also this is somehow reflecting the type of and the topics and the different talks that we have listened during this last 2 days. So I think that there's no much. I would have been more surprised if one of these portion would have been much smaller, but I think this is quite coherent with respect to what we are observing nowadays. And last but not least, the impact that for the industry is expected, and the uncertainty was very low, only 10%, and there is kind of a sort of a division with respect to whether it will be completely transformational or incremental, but for sure we can match these two items together in thinking of disruptive or impactful in the sense that definitely industry believes that generative Edge AI, again, we are not talking about generative AI, but generative Edge AI will be something that will definitely take major attention in the future, but already now. So to summarize respect these trends, I think what we can say is that adoption is something that is not really near term, but is not really something not long term, but it's near term. The small language model and cross-modal models are basically the thing to focus, to look at, and the innovation are quite balanced and spanning pretty much everything, different type of solution, and that this impact will be transformational and very strong for the industry during the upcoming years. And just the last slide, it's more like a reflection. It's perhaps we can double check perhaps during the first forum in 2026 what we'll have, but the feeling I get, and I got also during the last 2 days, is that we won't talk much about the new models perhaps, but we will talk a lot about the operationalization of this model and how put things together, especially if we think that these models represent kind of the base layer for agentic workflow, and then when it comes to agentic workflow and this type of pipelines, a distributed deployment, looking at the coordination, how information can be transferred over the network or over the internet, taking consideration the different tool chain, the different and the heterogeneity of the hardware. I think we will see more and more of this in the future. Also, we dedicated pretty much a big part of today on the different verticals. In my opinion, we will see a lot about optimization and very surprising results about domain-specific foundation models for the edge. I think that, as I mentioned earlier, also based on some results that I experienced in my research, there is a lot of work to be done when it comes to the specialization and quality of the answer that we can get in these small language models, especially if we are aiming for full automation in a specific context like industrial manufacturing, vehicular, and so on and so forth, or even simpler code generation for edge devices. I think there is still a lot of work to be done to the optimization, and perhaps We haven't heard much about RAG or fine-tuning, but I'm confident that this is going to be, especially from edge perspective, something that we really need to look at, and we will hear perhaps in more and more in 2026. And tooling and reproducibility, when it comes from the industry, will become a really competitive advantage. I think that whoever builds the easiest pipelines wins, and there's a lot of competition. It's a very harsh market, but yeah, it's very appealing area. And last but not least, I think we can really conclude also based on the experience that we have seen throughout this forum, is that the foundation, the Agile Foundation community, is somehow representing a catalyst of all this effort of this very wide ecosystem. We have a lot of organization involved, the different forums that are very helpful for sharing the kind of the state of the art of the development of these technologies. So I'm really looking forward to what is going to come next year. And this pretty much concludes my presentation. Thank you so much again, and happy to discuss with you, Danilo, if you have some question or additional insights that you would like to add here.
Great talk, Roberto. Really, this is what I think we all need, an helicopter view and of what's going on after 2 years. And essentially, you helped a lot to connect the dots. In these 2 years, we saw dots here and there, and but how to make a sense of it, that's really fundamental, especially I was touched by many points in your presentation, so let me try to at least mention some and open a bit a discussion with you, or sharing some more thoughts. So in one of your slides, I saw SLM and Edge AI very correlated.
Yeah.
So very provocative question. Does it mean that GenAI is Edge AI now, and Edge AI is now GenAI? I mean, in the understanding.
So I was very surprised when I saw these kind of two curves almost perfectly fitting, and it looked like that Edge AI is generative Edge AI. I have to say that I've been spending the last few years of my research on Edge AI, so I go to the interpretation that actually what we have been building in the past is turning to be very, very useful for building ecosystem respect what we can build nowadays with small language model. And I'm talking from model optimization to building pipeline and frameworks that can help to provision these services at the edge in an efficient way. So I want to have this this view rather than the generative Edge AI is now Edge AI. I think that also the consistency with pre-generative AI models is something that still need to be taken into account, because again, we can't fully rely on certain models. Again, the level of specialization that we can reach in this model is not impeccable. It was also mentioned in the earlier talk, these models are trained with a bunch of different data, so the hallucinations are actually quite remarkable still, especially for smaller models. So I think I want to see like Edge AI as all the experience that we have been building in the last few years as the cornerstone for building generative Edge AI systems, and that are of course relying on small language models.
Thank you. And you summarized very well all the expositions in 5 waves. Mm-hmm. So can we infer that the field is under consolidation? I mean, initially, maybe, you know, I've been told that generative AI, it's a hype. And maybe, you know, at the beginning, any new technology is fascinating, and maybe propose new advantages, new challenges. But then we need to wait a little bit to distill what's really matter out of a technology, and maybe this takes time. But in only 2 years, this distillation seems to happen, and your 5 waves, your summary seems to suggest so. Or any comments, or am I wrong?
No, I fully agree. Actually, I think that it's pretty clear the pattern that we have been observing, and these forums have been very helpful for kind of depicting clearly this pattern. Is that we start from vision, from the feasibility aspect. Can we really do this at the edge? But in just 1 year and a half, the landscape and ecosystem has completely changed. We are already talking about hardware acceleration, generative AI in MCUs, you know, which was perhaps something unthinkable back in the days. Again, of course, there is still a lot of work to be done, luckily, in the sense that the ecosystem needs to grow, in my opinion, when it comes to coordination and the possibility of deploying agentic system at the edge. We do have a lot of tools and possibility in the cloud. I don't need to name all the different opportunities that nowadays are possible, connecting tools. But for the edge, we need to make still some effort, right? Just to give you an example that just comes to my mind, we have had a lot of discussion in the last year about agentic protocol, mostly relating to cloud-based deployment. I think at some point we will need also to face the agentic protocol aspect in the context of edge. We will perhaps need and have different constraints, different requirements. So I think the ecosystem has been evolving quite a lot in many areas, and is still evolving in many areas. But I'm quite sure that there are also some areas that are not necessarily, that haven't been evolving as we were expecting. So things are definitely consolidating. But when it comes to you know, bringing RAG capabilities at the edge, or agentic protocol at the edge, we still do have a lot of increased, like better multimodality and quality performance at the edge. We still have some work that must be done in terms of consolidation and development.
Yeah, and you know, in these 2 days, we saw also that investment on generative AI from hardware company were already significant. I'm thinking about Intel, Qualcomm, today NXP, Alif. So it seems really, you know, when an hardware company does these developments, maybe this company already understood in advance that this wave was coming, and which further confirm that's not a hype. And then obviously consolidation appear, because also through hardware, you know, there are many opportunity to develop the software stack and the services and the tool and so on. So, you know, Roberto, was my initial thinking wrong that Gen AI was about a hype at the edge?
Perhaps we were all wrong. I think that perhaps the majority was skeptical at the beginning. I think the big question was like, why we need to do this, and do we really have the tools for doing this? And but then and this was again, things have been evolving so rapidly, and perhaps this was the perception that we had a year and a half. But then, connecting also to your last comment, the survey results that we got, which with insights that are coming directly from the from industry, right, and where we have a lot of hardware manufacturers, clearly show that people were already seeing this happening in 2025, 2026. Hardware was, in that pie chart, the most most represented and considered like the most impacted area. So I think that things have been evolving so drastically, and what the feeling of this is going to be a hype, which I also personally had and I was sharing, was incredibly, reverted to something that is actually more concrete than we could think at the time.
And so allow me a bit, Pete, because I think there are a couple of points here very important. We need to share with the community. We had this survey, and one of the answers I couldn't sleep on at night was that on 2025 Gen AI at the edge was expected to happen. So after this review of the results, of the outcomes, do you see a good match between the survey and what the people exposed in these 4 forums?
Yeah, I want to just jump in here on this one, because I think if we go back to the IDC conversation we had yesterday, Rob Tiffany was saying, like, we think about these different waves of generative edge AI, and some of it's how do we define generative edge AI? He was saying that, a corporation running an on-prem server with their own language model trained on their secret corporate data would be generative edge AI. And that's probably the first wave that we're seeing, is that people who don't want to put sensitive information into OpenAI's, system are running it locally. Even though it's probably NVIDIA powered and it's local. And then there's the other part of Gen Edge AI, which we're seeing too, which is really phones and PCs, right? So we're seeing language models running on phones, Qualcomm Apple phones, and that's another version of generative edge AI, which are both like scale markets, right? I mean, the market for corporate data and the market for phones and PCs is quite large. I think the thing that we haven't seen yet, and maybe this is okay because it takes time, is these more specialized commercial deployments of generative edge AI, that we think about, the talking car engines and the whatever, talking refrigerators and washing machines and other things. Like, we're just not there yet from a lot of reasons, from resources and semiconductors and RAM cost and things like that. So I think it is happening. It just depends on how you define it, right? So I think we're actually, if you think of those 3 phases, we're definitely in at least phase 2. And these phases will carry on for years, right? We just haven't hit the phase 3 yet. That kind of embedded generative agentic AI thing in an embedded, edge endpoint. That hasn't happened yet, from my perspective.
So Pete, you saw clearly from Roberto's summary that industry verticals were another outcome of these days. Are we ready for Gen AI blueprints, in your opinion?
Well, I think for those first 2 phases, like I said, they're happening. Corporations are looking for guidance on kind of more control over corporate trained generative AI systems, right? But I think for some of these embedded, kind of commercial things, I think it's, I think there needs to be some, serious use case driven analysis of what those blueprints should look like, right? And like the one we saw in Taiwan was the kiosk, was the customer service rep, where you walked up to it and started talking to it and asking it questions about Edge AI. It happened to be programmed, and it was a standalone Advantech box embedded in the sign. you know, and you imagine plopping those down across airports and other places, right? That are just, you know, so I think those kinds of blueprints are interesting, you know, and that could be useful to say, like, what would it take to really do a good conversational, focused, you know, generative edge AI implementation for an appliance. I don't know. Is it too early? Yeah, it's probably a little early, but certainly worth exploring.
Very good. So
I'm sure we'll see some talking refrigerators at CES, by the way. So regardless of whether it should be done, it will be done.
Yeah, maybe also a thermostat or a washing machine as well.
Yeah, I'm sure. So it's as you know, people will. There's this good old engineering question of what can we do and what should we do, and those are not always the same thing. So we will see some funky stuff with the people that are a little too far over their skis with this stuff, no doubt. But that's okay. That's okay. That's experimentation, and a high percentage of those will probably fail. But through those failures, you know, we will keep pushing forward. But I think the scale platform for generative edge AI these days are phones. You know, I think people are learning how to put more and more powerful models on these kind of either Bionic or Snapdragon platforms and things. And I think that's going to be very useful.
Very good. So I think we are at the end of the second day. Really grateful for Roberto to find the time and to share this summary. I think it was super useful.
Yeah, no, that was like a good wrap up. That was a good one. Thank you.
Any concluding remark, Pete?
Well, no, I think we saw, you know, I always tell people the diversity of the edge ecosystem is a feature, not a bug, you know, and we are in a very diverse ecosystem. And I think we saw a very diverse set of talks around this topic, which is great. And, you know, so people are pushing the envelope in different ways. And we'll see, you know, what kind of progress needs to be made. I mean, progress needs to be made on many fronts, right? Not just SOCs, but tools. I saw someone in the comments talking about tools. You know, of course, there's model sizes, there's, you know, training, there's all kinds of things that need to happen, orchestration and deployment and updating. All that needs to move forward for this stuff to be real. And I think we saw a diversity of the ecosystem coming together to try to address that. So that was my take, is that we have a very diverse ecosystem. I think each industry is having kind of its canonical use cases. I think we're already deploying in the kind of corporate edge market, and the phone market, and maybe the PC market. So, you know, it'll be interesting to see what the fifth one here looks like, which will be in spring of 2026.
Another challenge, Pete.
Another challenge. You know, maybe we're gonna have to expand it to 3 days or something. I don't know, because we just have a lot of talks, and a lot of good questions too. I really appreciate folks chiming in on the questions, and we'll have more to come on this for sure. So, and I really appreciate your support in this, and your, I would say, championing of this topic. Appreciate it.
You know, it helps me also myself to stay up to date with such an important topic.
Yeah.
Okay, very good. And thanks, Pete. First of all, thanks to you and the AGI Foundation to make space for that. I think it's very important. Me and the working group feel very, very well supported by the foundation, and obviously Rosina did a wonderful work. Cannot expect less, honestly, from her.
Yes. No, it was a lot of wrangling going on. So yeah, it's great. And just a reminder for folks, this will be on YouTube. The day one yesterday is already up there, and we will chop it up into more manageable pieces, but it'll be there, and people can go and look at it and in their own time zone.
Yeah. Please, if you can make it as soon as possible. There are also very interesting demonstration from an XP. We need to really appreciate they share today, and I think it should be part of the recordings.
Yes, and hopefully we'll see everyone in San Diego in March.
Indeed, with real demos.
Real demos, the real stuff. Yes, exactly.
Real stuff.
Great.
Touch and see. Yeah.
All right. Thank you, Danilo. Thanks, everybody.